So good afternoon, sir. Shall we start the session?
Yes, madam. Yes, we will start. Okay.
Okay, sir. So good afternoon, everyone. Welcome you all to the 6th day of the FDP on Advanced Technologies for Smart Power Systems. It's an absolute privilege for me to introduce today's distinguished speaker, Mr. MP Ganesan. Mr. MP Ganesan, sir, is an accomplished electrical engineer with over 3 decades of experience in the power sector. Born on May 16, 1962, he earned his Bachelor of Engineering in Electrical and Electronics Engineering from Coimbatore Institute of Technology in 1984. He began his career as a design trainee at Hindustan Reprographics Limited, Dehradun. In March 1986, he joined Neyveli Lignite Corporation as an assistant executive engineer at Thermal Power Station 2, Stage 1 in Neyveli, Tamil Nadu. Mr. Ganesan's dedication to training led him to serve as the training manager at the Power Station Training Center, an institute accredited by the Central Electricity Authority, Government of India. His expertise was recognized internationally when he served as an electrical instructor for Mitsubishi Heavy Industries Limited at Gaslan 2 Power Plant Training Center in Saudi Arabia. There he developed advanced training programs for Saudi technicians under the Saudi Station Initiative. Upon returning to NLC, Mr. Ganesan held several key positions, including Deputy Chief Engineer in Power Station Engineering. As Deputy Chief Engineer at Garsing Sar, he established and organized the Operations and Maintenance Electrical Division, contributing to the plant's commercial operations. In his roles as Chief Manager and Deputy General Manager, he oversaw the design and engineering of renewable energy projects, including a 51 megawatt wind power project and a 10 megawatt solar power PV power project. He also led the project formulation and coordination for large-scale solar initiatives, notably the 500 megawatt and 709 megawatt solar power projects, and served as the project in charge for the Andaman 20 megawatt solar project with an 8 megawatt hour battery energy storage system. In June 2020, he was appointed as the Chief Executive Officer of Coal Lignite Urja Vikas Private Limited. Beyond his professional endeavors, Mr. Ganesan has been actively involved in various organizations, serving as Joint Secretary and Vice President of the Graduate Engineers Association for Thermal Power Station 2, Joint Secretary of Neyveli Tamil Sangam, Secretary of Nethaji's People Forum, Treasurer of Lignite City Film Society, and as a State Committee member of the Breakthrough Science Society. Since June 2022, he has been sharing his extensive knowledge as an external faculty trainer for the National Power Training Institute and offers freelance consultancy services for solar and battery energy storage system projects. He has been elected as the State Executive Committee member of Breakthrough Society in the recently held Science Conference in Queen Mary's College, Chennai. Today, he will share his valuable insights on solar technology and energy storage, drawing from his vast professional journey. We welcome you all to share your knowledge in this FDP, sir. Welcome, sir.
Thank you, madam.
Thank you, sir.
Let me share my slides.
Okay, sir.
Green greetings to all the faculty members and research scholars and students. Especially, I have to thank Madam Professor Cynthia, Madam, who had given me an opportunity to share my ideas, thoughts, and our experience with our faculty members through the ATL online faculty program. AICT is going on improving its activities. Through online, this faculty programs is conducted in hundreds of universities, higher education institutions. Likewise, Nurul Islam Higher Education Institute, which is a Nurul Islam Center for Higher Education, is a very reputed one in the southmost part of our India. And I'm very glad to share with my knowledge. In the advanced technologies for smart power system, that is a very right topic that you had selected from your department. And a part of it, I would like to present my topic, solar technology and energy storage to you people, because it is a recent and it is a blooming topic. And with the smart systems, how it is to be integrated more, so that whatever the challenges in this field will also be taken care. Before to start enter into the challenges, first I would like to start with some basic aspects that can be dealt, which will be which will make a depth of sensitization to our faculty members as well as our research scholars, which will be which will arouse broad thinking in the area of our smart solar technologies and energy storage systems. So to begin with, let us understand where the fuel for the solar power plant comes from. It is the solar radiation, which is radiant energy emitted from sun. As we know, it is only a light, but many of the people are having a misconception that the heat that is being received in our Earth's surface is getting converted. No, in our solar technology, PV technology, we are particularly converting the radiant energy, that is a light. Light means it is a basically, in basic science, we say it as an electromagnetic wave. So this electromagnetic waves, the Earth intercepts it, and a fraction of that vast amount of radiant energy that is emitted from the sun is received. An optimum amount is received. That's why life is sustainable in our Earth. And 98% of the total energy, it lies in the spectrum range of 250 nanometer to 3000 nanometer. Half of the radiation, that is in the middle range, it is the visible short wave. That is a thing which is useful for us to convert into electricity. So in the electromagnetic spectrum, the visible short waves are used for our conversion. That is a fuel for us. So freely available fuel, daily it is available in the daytime. And other half in the electromagnetic spectrum is, one is the ultraviolet, visible, then infrared. A large part of infrared portion is also there. Ultraviolet, as you know, within our, when it is entering into our stratosphere in the ozone layer, it is getting absorbed. There is a protection for our whole human being, for our life systems. But that ozone layer is getting damaged. That is another topic that that topic I'm not going to deal. But why we go for solar is because of that reason. We already punctured the ozone layer. So ultraviolet rays are absorbed in that ozone layer. It's a very good protection for us. Then the solar radiation traverses into our atmosphere. It is getting scattered, reflected, and absorbed by the air molecules, aerosols, and clouds. There is a direct radiation also. We receive it in the Earth. So this is the basic fuel which I receive for my conversion in the Earth. What is the characteristics of my fuel? Basically, in the sun, what is happening is nuclear fusion process, thermonuclear fusion process. As you all know, we have two nuclear systems processes, that is the nuclear fission and nuclear fusion. Nuclear fission is the normally what we use in our Kudangulam power projects, in Kalpakkam, Tarapur, in all our nuclear power stations, wherein we divide the nucleus of uranium and we get the enormous energy that is being converted into steam. That steam is rolled in the steam turbine connected with this our synchronous generator Thereby we generate power. So 1000 megawatt single generator would be possible using nuclear fission process. But what happens in sun, where my fuel, readily available fuel is getting emitted, is hydrogen nuclei. It is at the center of the sun. It fuses into helium. Thereby, I get this enormous energy. During this thermonuclear fusion process, we get this enormous energy. And this binding energy is around 3.83 into 10 power 26 watts from the entire sun. And it is having a outer shell photosphere with a diameter of 1.39 into 10 power 9 meters. My sun, that is the average distance between the Earth and the sun is around 15 crore kilometers. 15 crore kilometers. So my fuel is available away from 15 crore kilometers. It is traversing from that distance and it is reaching the Earth's surface. That 15 crore kilometers, that is around 14.96 crore kilometers, what we say it as a one astronomical unit in the astronomical studies. That is one thing. So the solar radiation at the unit surface area at the sun surface is around 6050 degree Kelvin, and the energy, enormous energy available is 6.33 into 10 power 7 watts per meter square. But what I receive per square meter area in the surface, in the Earth's surface, and then average, it is around only 1367 watts, around 1.3 kilowatt only I am receiving per square meter in the Earth. So that value is taken as a solar constant. That is for our purpose, we have taken it. The intensity of the radiation at the one astronomical unit is called as solar constant at the Earth's surface. That is 1367 watts per meter square. This is the fuel available for me in the daytime. Further, we will study about this fuel. In the solar spectrum, as we had already discussed, electromagnetic spectrum, it is 200 nanometers up to 2600 nanometers. 45% of the sun's energy is in the visible range, that is in the 0.3 micrometer to 0.7. Others lie either in the UV or in the IR, that is in the infrared region. So around 1% we say as the ultraviolet. Almost 54% big portion is in the infrared, which I am not going to use, which will not be used by our photovoltaic. We convert only the visible spectrum, which lies in the 0.3 to 0.7 micrometer range. So wherein we get a spectral radiance of a higher value as per the curve, what you can see. So the solar spectrum further, if you see in the curve, you can see ultraviolet in the left side, visible range in the middle, and a large portion of IR in the right side. So individual particles, we name it as photons. These photons have a single wavelength, and it depends upon the energy content. The photon varies. So these photons are coming. This range of wavelengths in this solar spectrum directly due to collection of photons of many different energies. So wavelength, if I say a range of wavelengths, it is a collection of photons with the different energy levels inside. So performance of the solar energy utilization devices like solar photovoltaic devices, distribution of this photons is the main thing that is to be taken care. So a wide energy spectrum will be available for me, which decides the performance of my solar PV photovoltaic modules. There is the energy utilization devices. In the ground level, whatever the solar radiation I receive, this is the curve from the morning, early morning, 6 o'clock to evening 6 o'clock. This is the
Excuse me, sir.
daily variation.
Sir,
Yes, madam.
sir, your slide is not moving.
Okay. I will try again. Is it okay, madam?
It's okay, sir. Okay, sir.
So in the daily variation, you can see a very small amount of insolation will be available in the early morning time. It will be going up to a peak value in the noon, and it will be coming down to the lowest value in the around the evening time, that is 6 o'clock. On the clear days, around 80 to 90% of a direct radiation we can receive from the Earth's surface. On the cloudy days or foggy days, we'll be getting a very less component of direct component, and that is the direct component is a very important one for us, which will be converting into our solar energy. The diffused component will also be used, but in our case, that is also used. But in other applications like concentrated or small areas, using mirrors and lens, it is not used. But in our case, we use that also. That is a solar PV photovoltaics. That is the thing largely you can see in all over India we have installed. Till now, we have installed around 96 gigawatt, that is 92,000 megawatt of solar energy. Almost around 2030, we have to reach 50% through renewable energy. The total installed capacity in India is 462 gigawatt. Main portion goes to the fossil fuels, which is around 52.9%, around 244 gigawatt, including coal and lignite. Hydro around 47 gigawatt. Solar is around 92. Wind is around 48 gigawatt. And non-fossil fuels, so totally it comes around like hydro, solar, wind, and other biomass, all these things together. It is 217 gigawatt presently, including the hydro, 47%. Soon, this variation is going to include more, and we are going to include in a higher proportion. Like solar is going to take a value of around 300 gigawatt by 2030. That is the target we have fixed, so that the climate change and other challenges can be met. So in this case, in our solar radiation, when it is passing through the atmosphere, it is getting absorbed, reflected, scattered. These are the three phenomena which is happening apart from the direct radiation. So the atmosphere causes a reduction of the solar input by, in general, 30%. Though ultimately we receive 1000 watts per square meter at noon. So this is the value. Even though we say 1327 is a solar constant, we receive only 1000 watts per square meter at the noon time. Suppose if I put a 100 megawatt power plant, reaching 100 megawatt at a particular noon time in a year, in a spread of 1 year, it will not be more than 20 days. In our experience, it is even less than 20 days. We have put power plants in Vardhanagar, Arbukotai, Tirunelveli, Tenkasi, in this belt. In Rajasthan also, projects are going on. In Gujarat also, projects are going on. But our experience goes that the entire capacity, installed capacity, we are not able to reach. And also intermittency and variations are also, it is there. That part only we are going to deal more in our challenges, as well as the in the smart system, how it is going to add in the later stage. So whatever we say 1000 watts per square meter at the noon, it's the installation. That is the value, it's a standard value which is used for solar PV modules to test what is its performance of the module. Most of the time, the incident energy is well below the angle of incidence. Total received energy in 10 hours time, morning 6, if you start. Averagely, you will get only 10 hours of daylight. Per square meter, you will be getting 5 kilowatt hour of energy unit, converted energy unit that will be having. Recently, in the central government, they had announced the PM Surya Ghar scheme, under which people are given subsidy to put solar rooftop. So people can install up to 3 kilowatt. So for 3 kilowatt, they will get a subsidy of 78,000 rupees. If they put 1 kilowatt, some 30,000, 2 kilowatt means 60,000, 3 kilowatt means 78,000. So if they put the 3 kilowatt, they will be getting around 15 kilowatt hour. Daily 15 units they can generate, and they can adjust it in their day and night consumption. Whatever the excess, if it is there, then it will be fed to the DISCOM, and DISCOM will receive it, and no payment will be made. Only adjustment will be done on the billing basis. So this is another aspect. So on an average per square meter, I will be getting 5 per kilowatt. Per kilowatt, I am getting 5 units. If I put and if I install 1 kilowatt of solar PV modules, I will be getting 5 units. So 3 kilowatt means 15 units I will be getting. This is the energy. This is the fuel which I receive, which is getting converted in our system. The actual solar energy at the solar collector, it depends upon the position of the earth. The earth is rotating, and also it is having a 365 days changes. Totally it is having a changes, and its orientation and the time and the weather condition. All these things decides the actual solar energy. These are the factors which is affecting us. So a constant and steady energy, steady electrical energy conversion is not possible, and there will be a variation, there will be intermittencies. So due to which the grid will also have challenges when we integrate such a type of varying intermittent energy source. That is the electrical energy which is being coupled with our grid system. So this is why we emphasis on these things is these are the points which we are going to deal, how to deal and how to understand it, how to make it so that the grid will be stable when we connect it with the RE systems. So in a graphical method, you can see from the sun, whatever the radiation is being received at the Earth's atmosphere, it is absorbed in the aerosols and reflected from the ground. That is one part. A direct radiation is the main part which is being converted, which is a main conversion. And another one is the diffused one. Another one is the reflected one. So these are the types of solar radiation fuel that is being injected over the solar PV module. An atlas of solar atlas is also made, and in which the solar radiation, so global horizontal radiation, GHI, normally we say GHI, for each location is mapped, and an idea is given where we can install this type of solar projects, which will be helpful to yield, to harness more solar power. That is in the southern part, in patches of areas, it is possible. In the western part, totally in the Gujarat as well as the western part of Rajasthan. It's a huge support is available so that around 2000 kilowatt hour per square meter is available. In our area, it will be around 1800, 1700, but here it is 2150. Other
Sir,
parts it is, yes, madam, 1850, like that. It is in this range in the middle part. So now we can find more projects are coming up in the Rajasthan, Gujarat, and in the southern side of our Tamil Nadu belt. Yes, madam.
sir, the slide is not moving. It's still.
It is not coming here. India map is
Six,
not coming here.
it's now in the sixth slide, sir.
Oh. Whether it is moving now? No.
No, sir. So you,
What I have to do?
so from the in the top, you put that press that from current slide.
Okay. Is it okay, madam, now?
Oh no, sir. So
It's
you
not
just
moving.
change the next slide, so we can see. No, sir, it's not
No.
pressed. That no. From current slide button is not
Yes,
pressed,
yes.
sir.
From front slide only it is.
So go for the next slide, sir. Whether it's moving, I can see.
Is it okay?
No, once you're
No.
clicking, it's there. Then it's not moving.
Now it is okay.
It's in the solar irradiation slide now. So you
Ah.
try for the next slide, sir.
Okay.
Next slide we are not getting. It's in the solar irradiation.
Oh.
Hmm.
So it is still in this one.
Yes, sir. Yes, sir.
Now India map is coming?
No.
No.
It's in solar irradiation. No, sir.
What is this?
So you just click the slide number 7 you have pressed now. So click that number 8, 8th slide. So we'll see whether it's there. So like that, each slide you click, sir. Then it will be visible.
No.
Now it's in the 8th. My map you are seeing, India map.
Okay. So this is the solar map, solar atlas, we can say. Through various data, particularly NASA data is taken and the map is made. And where the potential is more, we can install the projects, solar PV projects. So you can find Gujarat and Rajasthan, western part of this portion is the main potential portion. In Tamil Nadu also, in some of the portion, we can have the potentiality. Even then, the other portion also, 1850, 2000 radiation. It is there. That is the kilowatt hour per square meter. That is the irradiation value that we can say. Solar irradiation is the output of the light energy from the sun measured at the Earth's surface. That is the solar radiance. That is the definition. So it is in kilowatt hour per square meter. That is the value. We say it as a, when we measure it directly, it is called a global horizontal radiation. And apart from these areas, you find some areas in the Ladakh region, in the Jammu Kashmir and the Ladakh region. Particularly not Jammu Kashmir, now it is only Ladakh region. This Ladakh region, we say it as a cold desert. This is having the highest potential of irradiation as well as the conversion also. As the area is also having a cold atmosphere, and the conversion efficiency will also be higher, and the irradiation values due to diffusion and reflection will also be higher. And there's also a potential area around 25,000 megawatt is possible in this area. Only thing is environmental hazards and this Himalayan ranges, all these things are inhibiting, and we are not able to explore projects. Only small projects are installed, not the ultra megawatt projects are not, could not be brought. Then another main important aspect is the transmission line. We have to lay minimum 900 kilometers in the Himalayan terrain to bring the bulk ultra megawatt power, ultra gigawatt power to the mainland so that we can utilize the power. So that is also another challenge. That's why this area, exploitation of this area, that is utilizing the solar potential in these areas are very not conceived now, even though there is a plan. In Andaman Nicobar, where we had done 20 megawatt solar project with 8 megawatt hour battery energy storage system, wherein the average solar irradiation, global horizontal irradiation is around 1,700 only. It is not a much bigger one. But even then, why projects are selected there is it's an island area. So for electricity, the government has installed diesel generator sets. Around 65 megawatt diesel generator set is installed in the Port Blair itself for the electrical supply. And in all the islands, around 1 megawatt or 500 kilowatt diesel generator sets are installed. So a huge cost is being spent. Per unit, the cost of the electricity is around 26 rupees in Andaman Islands. That's why it was planned. Whatever the irradiation available, even though it is in the lesser range, let us install the solar projects so that the cost will be very less. And intermittencies and the cloud passing and minimum of around from May 1st to September, this period, it's a fully rainy season as well as a cloudy season. That time the output will be very less. Even the value will be around 50% of the output only you can receive. So even then it is installed there with the higher cost, but it is to replace the diesel power. This decision is taken and it is installed. First time in India, megawatt, that is a megawatt hour scale energy storage system is installed in the Port Blair area. Now, if we find out the measurements of this radiation, direct radiation is taken by heliometers. Global solar radiation is taken by pyranometer. What we use in our power plant, all the power plant, it will be a thermoelectric pyranometer value. So that pyranometer value will give the electrical signals, which will be converting the solar radiation. And that value is taken to our SCADA. And we will check the performance of the plant with respect to this global solar radiation. What is the performance of the plant? For our study purpose or research purpose, we can have diffuse measurements separately, reflected measurements separately, and solar spectral irradiation and turbidity meters separately, that is the sun photometers. These are all the other meters which is used for other purposes. But for our power plant purpose, we use only the pyranometers, which measure the global solar irradiation values. These are the pyranometers which is used for our measurement purpose in the power plant. This can be used for our labs also. This is the pyranometer. So from this pyranometer, we measure the value and we take it to the SCADA for our measurements. Others are heliometer, heliometer with the tracking, with the geometer, radiometer, and radiometer. Like this, various types of meters are there, which is not of our concern. Only for research purpose it is used. Pyranometer is the widely used in all the power plants, and it is to be calibrated every time, 6 months once, and the measurements are to be recorded. And the minutes level data will be available for us. That is the main thing. Minutes level, the radiation data will be available, and in minute level, it will be compared with the performance of the plant. These are the pictorial representation of the pyranometer. That is the direct measurements by the pyranometer, and reflected, diffused all together will be available when we put it as a in a measurement angle. So this measurement angle is a very important aspect. It depends upon the location. Suppose Neyveli means 11 degree. Maybe Kanyakumari will be around 6 degree latitude. So it depends upon the latitude angle from the equator. The angle of measurement also decides, as well as the angle of solar PV modules also are to be mounted. So that is a very important aspect that we have to understand. All the solar PV modules, whichever which is erected in the power plant, they should be taken in a particular angle. That angle is decided by the location's latitude. As we are above the equator, we have to place it towards the south, so that when the sun traverses from east to west, the entire period, it will be receiving the solar radiation, and the energy conversion is possible. So all the solar panels, all the solar PV modules, whether it is a rooftop or for the ground mounted large scale projects, everywhere, all the projects you can see the solar PV modules are mounted towards the south. That is looking towards the equator and at an inclined angle of with respect to that latitude of the location. That is a very important aspect that we have to see. So for capturing the solar energy, there are different methodologies available. Passive solar technologies and active solar technologies. Active only, we are saying that photovoltaic, that is directly whatever the electromagnetic radiation we receive, that can be converted directly into electrical energy. Solar thermal collectors are also active thing. And captured as heat, that is another technology that is not become a commercial one. It's only a pilot stage, and in study purpose only it is there. Solar collectors are used for the electrical conversion. So in the direct conversion of the energy, as it is basically it is generating DC power, all the photovoltaic modules, whatever the voltage and current it is coming out from the solar PV module, will be a DC power, positive and negative will be there. That is being fed to the inverters. In the large scale projects, we have central inverters of capacity of 2.5 megawatt each inverter. And that inverter converts the DC power into AC power, and it is getting interconnected with our grid system, AC main supply. The sunlight, which is in many spectrum, it's having a lower energy of 1.1 electrovolt with the high energy of 3.5 electrovolt. These are all coming to our photovoltaic system. And basically our solar photovoltaic PV cells are semiconductor devices. PN materials are there. P-type and N-type, and PN junction is also there. They are designed in such a way to capture the photons and convert this energy, that is the electrical energy. Normally, these solar cells are arranged in a series manner and in parallel manner, so that in a PV module, we will be getting an output of around 500 watts, 550 watt, 560 watt, 600 watts is the latest range of modules that is available. So these solar cells is the main heart of the system in the solar PV module in the entire process. This solar PV cells, which converts, these are the cells, these are the PN modules. These are the P-type and N-type semiconductor cells, which converts the energy. Here you can find, for a small rooftop of 3 kilowatt, you can find from morning 6 o'clock, the generation starts, and due to cloud passing and other disturbances in the atmosphere, the generation is going down. There are fluctuations, there are intermittencies, and it is having a pulsating output. And the production stops at 6 o'clock. So this is the nature of energy generation that is available for us in our grid system. It's a 3 kilowatt system, but in our large scale systems, this drop will be having a big effect in the grid disturbances and the grid stability and the grid efficiency also. So in that time, we have to make ready reserves available in the grid system, so that the solar, that is a grid dispatch center, load dispatch center, will manage the show without any change in the frequency and voltage. That is a challenge that we have to see. So how the solar PV module works? It's a PV cell N-type semiconductor layer using silicon as a substrate material, over which phosphorus is coated. P layer, that's a P-type material with the silicon and boron. Silicon is a substrate over which boron is coated. This is the basic process, N layer and P layer. This is the basic photo cell.
Sir.
Yes, madam. No change.
No, sir.
Oh. Is it okay, madam, now?
Yes, sir.
Okay. So this is the basic photovoltaic cell. The cell will be of the size of 156 mm to 156 mm square type. It's thickness of the solar cell will be around 200 microns only. It's a very, very, very flimsy plate. Small, that is a 200 micron is the thickness of this one. So the handling of this one to make into a solar PV module, manually it is not possible. Normally, robotic systems are used to take the solar PV cells to get arranged and interconnected to form the solar PV modules. So whenever we go for solar PV module manufacturing, you can see solar PV cells are handled by the robots with the vacuum picking up. As per our electronics theory, we have the valence band and conduction band, P-type material and N-type material. In between the conduction band and the valence band, we have the band gap energy. So when the photons are hitting over the N-side, N-type and P-type materials, holes and the electrons start moving from the valence band to conduction band. That is the generation method. So when the photon hit over the holes from the valence band, it goes to the conduction band. And this is the electrical current flow. Electron hole pair is getting moved. During this process, we find there is a heat generation within the atoms. So this heat will be available in the surface of the PV modules. Suppose the atmospheric temperature is around 40 degrees centigrade. The heat generated due to this band gap energy release and due to the photons hitting over the holes, and it is moving to the conduction band to capture the electrons. So due to which the heat will be around 60 degrees centigrade. So this is one of the disadvantage in the solar photovoltaic system. This is at the highest peak time. That is at 40 degrees centigrade, you will be getting a 60 degree centigrade. So the atmospheric air, natural air is used to cool the solar PV modules. That's why in each solar PV module, when you go for a selection, you have to find out what is the thermal coefficient of that module. Thermal coefficient is one of the measurement to check the efficiency and performance of the solar PV modules. So this is a solar, there is a spectral photon flux density region. This is the energy that is getting released from the valence band to the conduction band. This is the arrangement of one solar PV cell. We have P-type semiconductor and N-type semiconductor, which is the heart of the system. And in between this is a PN junction. And in the top portion, we have the front contacts. In the back portion, we have the back contacts. These contacts are silver ribbons. They collect the electrons, which is being coming from the valence band to the conduction band by the N-type semiconductor. It is getting collected from the front contact as well as from the back contact. So these contacts, there is a silver ribbons, are made into the positive and negative for each solar cell. This positive and negative solar cell terminals are getting interconnected by soldering with the another solar cell. Thereby, around 60 or 100 solar cells are arranged in series and parallel to get 500 watts output. Normally, the output DC value will be 50 volts DC, 10 ampere will be the current. So 50 into 10, 500 watts will be the output. This 500 watts will be available at the standard test conditions, what we told as a solar constant. That is the 1000 watts per square meter. At that irradiation value, it will be having an output of 500 watts. That is 50 volt and 10 ampere current output will be coming out. And over this, we are having an anti-reflection coating and transparent adhesives are there, and cover glass, a temper glass will also be there. And all these things are made into laminated one, and over which the cover glass, that is a temper glass, will be put up over the top. In the back side of this solar PV module, we'll find the end termination points and bypass diodes are there. If any shading, a part shading or any bird droppings are there, any dust is there in part of the module, those portion will not get proper energy. So those part will be getting bypassed through the bypass diodes in the circuit. So that is the arrangement in the solar PV module. So in the end, we'll be having a positive and negative terminal cables, which is coming out, which will be used to interconnected with the next module. So this is the arrangement of the solar PV modules. Here we can see the solar PV modules. One module with the P-type and N-type silicon, and a junction is available. And this is made into a solar PV module by interconnecting it. Two ribbons are traveling from cell to cell, and they are getting interconnected, and they are taken to the top and bottom side for the further interconnection to make series and parallel paths, so that 50 volt DC will be available, and 10 ampere current will be coming out from the solar PV module. In this one, you should understand one more point. This basic silicon, which is our ordinary earth material, is having a purity of 99.99999 for this semiconductor device, that is a solar PV module. For our other microelectronics and other materials, we have a purity of 99.99999 12 N. But here we use 9 N. So this silicon, that we say it as a polysilicon in the market, it is not manufactured in India. It's a very cumbersome process, even though quartz is available, 99.99% is available. Now attempts are being made, and some schemes are being announced to manufacture it. The main manufacturer is the China, so who is supplying the entire silicon material for manufacturing of cells and modules. So around 100 manufacturers are available in India for manufacturing the modules. They purchase the solar cells from the international market, and they assemble it, solder it, and assemble it, and make it into a solar PV module, sell it in India. Solar cell manufacturing is recently it is picked up. Tata has installed recently one plant in Tirunelveli. Adani is also having another plant. So these are the very limited players are there. Only they are only supplying it. In the many of the projects, this solar PV cells manufactured in India are preferred, but the cost is more higher. And with respect to international market, particularly China rate, it is having a 25% higher. The values are higher.
Sir.
Yes, madam.
So
it's not moving.
Not moving, sir. Sir, use full screen mode, sir. Full screen mode.
Full screen only.
It's actually it's not in the full screen mode. Otherwise, you use presenter view is there, right? That.
Yes.
Actually.
Now it is there.
Slide is not moving. Once you're clicking, it's okay. Then after next slides, they are not moving, sir.
Oh, now?
Now it's in the concept of solar PV technology slide.
Okay. That's the thing.
Sir, move for the next slide, sir. Next slide.
Now it is not coming, yeah?
No, sir, no.
Okay.
So you just click that slide number, sir. 20. It's now 20, sir. You click 21. Like that. You click while moving, sir. Then we can see. Okay. Sir.
Now it's okay?
It's okay, sir.
Okay. Now we will enter into the energy storage topic. Electrical energy, as it is to be consumed instantly, that is a limitation. So basically in the generation area, we cannot store it. We can store it as a fuel only. So we have to transmit it, and it is to be consumed. So in the energy transition, the decarbonization era, 50% of the immediate capacity we have to use the non-fuel. That is our target. And net zero ambitions are also there. So a greater penetration of the renewable energy, particularly solar, which whenever it is available in that time, it is to be consumed or it is to be stored. That is the one constraint that we have in this source of energy. Apart from this, this renewable energy, particularly solar, is the intermittent and grid integration challenges are much available, much that we have to face. And energy storage solutions to achieve the flexibility of the system, as well as to enhance the grid availability, and we have to increase the power quality. That's why we need the energy storage systems for these projects. Till now, till around 92,000 megawatt, we have injected into the grid. But till now, we have not yet installed bigger energy storage with respect to manage the intermittency of the solar power. So if the penetration is becoming more and more that time, there's no other go. We have to go for energy storage projects. Now it is moving, madam. Is it okay?
Yes, sir. Yes, sir. It's okay, sir. Thank you, sir.
So recently in our market, for installing the solar energy, that is the battery energy storage system, around the anticipated requirement in the next year is around 35,000 megawatt hour that is required. But till now, we have not reached even 3.3 gigawatt hour. We have not yet reached. That is a very pathetic situation. 3,300 megawatt hour only could be installed. Because there are many constraints in it. The technology is the lithium-ion batteries are mostly used in many places. That is one thing. Now let us see what is the type of applications we have. Power and energy application. We divide this energy storage into two major. That is a power application and energy application. What do you mean by power application? This power application energy storage system will be discharge its energy in a lesser time only. As you had seen earlier, that whenever there is a dip of solar energy, solar generation, immediately to make up that time, around 15 minutes to 30 minutes, it can manage and it will discharge. And when it is getting normal, it will charge itself and it will be making it ready. So this will be available for frequency regulation as well as renewable firming up. So this application is called power application. Suppose the frequency is going down, consumption in the grid is going up, generation is less. Instead of 50 hertz, I am reaching a point of 49.5. So in that time, to make up the further if it is getting down, it's having a downward trend, then immediately I have to find out a backup resource. So battery will be the one of the backup resource for me, and I will inject the power from the backup source. And in the meantime, of around 15 to 30 minutes, I have to make arrangements so that, or I have to find out from the solar, from the renewable energy, whether it will be getting picked up or not. So this is one way of application that is called power application. And renewable firming up. As we had seen, this renewable energy is having so much fluctuations. We have to firm up the power for the grid applications. So for that purpose also, power application is used. The next one is the energy application. Energy application, normally it will have a discharge time of 2 to 4 hours. See, in the daytime, you have the generation. A part of the energy or a major portion of the solar energy excess, whatever is available, it can be stored in the battery energy storage system. And it will be getting discharged in the peak hour, the evening time, evening 6 to 9 or 5 to 9 or 6 to 10. In the evening peak hour, it can be used. Or in the morning peak hour, that is morning 5 o'clock to 9 o'clock, in the peak hour also, it can be discharged. So it is called energy shifting, time shifting, or peak shaving. So this application is called energy application. It is having a prolonged time period of discharge. The battery should have the capacity to discharge in a prolonged way. So in the first one, power application, the characteristics of the battery is different from the characteristics of the battery system in the second one. There are so many applications, like there is a energy devices, energy discharge devices, energy storage devices we can find. But normally in the market, the main thing is our lithium-ion batteries, which is having a life of 10 years and which suits either for the power application or energy application with respect to charge time and discharge time. It can be selected. Lead acid batteries are the batteries which is in the next to it, but widely used, but its life is only 3 to 4 years. And other battery systems are completely, they are all in the development stage only, the pilot stage only. Low batteries are mostly used for energy applications. For the minutes and seconds, we cannot use the flow batteries. Other nickel cadmium batteries, other batteries are also only in the development stage only. It is not come to the market, bigger level. And there's a pumped storage system for bulk power management. We are having a pumped storage system. In Kadambari, we have already installed and it is in service for more than 20 years. 800 megawatt plant is there, hydro plant, in which we have two dams. In between this, the power is the hydro power is run either at the motor mode or in the generator mode. Same system with the whether as a pump or the turbine, the system will be used. So it is used only for the energy application, only in the bulk load application only. For the minutes or hours in seconds level, we cannot use it. That is for the power application, it is not possible. So for the first one, power application, this is a power smoothing application. You can find the red color, the intermittency of solar power, which is fluctuating so much. So by attaching a solar, there is a energy storage, battery energy storage system, we can smoothen the power so that the grid will not get disturbed. Challenges will be managed and the voltage profile will be safe in the grid. So for that purpose, it is used. This is the thing we are having in our Andaman. This is the application we have, so that a sudden drop in power will not affect the small grid which is being managed by the DG set. Will be managed by the grid. We are not having any other application. Only the power smoothing application of 8 megawatt hour battery system, which is supplied by the LG Cam, which is the lithium-ion batteries from South Korea. We purchased, and this is used for our purpose. Another one is the energy application. So in the average demand time, first we have to charge the energy storage system, and during the peak demand time, we have to discharge it. So for a period of time, for 3 hours, 4 hours, 5 hours, in the peak demand time, we can discharge the power. So to manage the demand curve and to maintain the average demand during the peak demand time, this energy is released. This is the energy applications. This is the thing now. Around 35,000 megawatt hour we have to install in India in various places, and it's to be attached to the 400 kV grid system or 720 kV grid system, so that in the national grid, whatever the RE penetration more, it will be managed by this sources. These are the suppliers: NGK, Japan, Leclangy, Germany, ASIS, Australia, Raycam, Rocket Battery, Excite, and integrators like ABB, Alstom, L&T, Tata, Juvi. These are EEI, Italy, Schneider. These are the people who are in the battery energy storage field. Is it moving, madam?
Yes, sir. Yes, sir.
Okay.
Now it's power smoothing application slide.
Yes.
Okay, okay, sir. Thank you.
So energy application already you had seen? Energy application?
No, sir. No, sir. No, sir.
Now it is available?
It's available, sir.
Okay. This is the thing I explained. Out of
Okay,
2
sir.
applications, this is the second application, energy application. During our peak time, whatever the stored energy during the off-peak time will be discharged by the battery energy, so that for 3 to 4 hours, the peak demand will be managed in the grid. This is the energy application system. Some of the suppliers for the energy storage system and the integrators are also there. These are the battery suppliers. They are the integrators, where they purchase the system and battery, and they will make it into containers, so that this battery containers will be coming to the site and it will be getting erected. So mechanical wise, the storage devices, pumped storage, flywheel, compressed air, it is there. Pumped storage is also another attempt which is being made now all over India, so that it will be brought out within 5 to 10 years, so that the energy storage issues will be taken care. But mostly now the electrochemical, particularly the lithium-ion batteries are being explored more, so that 35,000 megawatt hour batteries will be installed within 2026-27. Capacitors and SMEs and molten salts are other attempts. These are all in the technology stage only, developmental stage only. This already we had seen. So this is the there's a scheme diagram. So battery is there. There is one battery management system which measures what is the condition of the battery. What is the discharge level, what is the depth of discharge, what is the density available. All these things will be measured, and accordingly commands will be given to the power management system, SCADA, so that the power conversion system, which is having an inverter and converter, which will be used for either charging or discharging. Either the battery is to be charged or discharged. That will be decided by the power management system, and it will give the command. Accordingly, the PCS, power conversion system, will operate. And in turn with the transformers, it is getting connected with the grid system. This is the general base arrangement which is used all over world. These are all some of the battery parameters which are highly useful for various types of batteries. Energy density, cycle life. If you see the cycle life of the lithium-ion batteries, as we say 4,000 to 10,000 depth of discharge. So this we calculate around 10 years will be the lifetime. Lead acid will have the very less 1,500 to 2,000 depth of discharge. And advanced lead acid batteries are little better, but even then it will be around 4,200, and only 50% only depth of discharge possible. In lithium ion, you can have 80%, even we can have technology for 100% also, but normally we limit it to 80%. Sodium sulfur is also another one, but this Japanese technology, NAS, is under development stage only. Flow batteries are having 100%. They are electrochemical batteries. Self-discharge is also very less for lithium ion. Others are the higher range. So the efficiency wise, the DC to DC efficiency is 95%. Charge and discharge up to 10 times of the value. 10C charging, we say. For energy and power application, we can make for lithium ion. And lead acid only 2C, and alkaline batteries only 5C, it is there. But lithium ion is having a higher capacity of 10C. And memory effect, there is no memory effect, but in the alkaline battery, there is a memory effect. So whatever the earlier charged value, only up to that value, only you can charge it. Safety wise, it is a thermal runaway chances are there. It's a medium level only. So we hope to maintain lithium ion batteries at 25 degrees centigrade. All the containers, that is one of the major auxiliary supply, auxiliary consumption for the battery system using the lithium ion. So the present installed capacity in the 2,200 megawatt hour under construction is 16,000 megawatt hour. Anticipated requirement is 35,000, and anticipated requirement is around 2,08,000 megawatt hour in 2029-30. Recently, the Solar Energy Corporation of India has issued tender for assured peak hour supply for peak hour like energy application. And developer has taken it, and 200 megawatt for 4 hours they will supply. The rate of the supply, that's electricity, will be 8.5 rupees per kilowatt hour. That is the main worry. This battery energy storage system is a bit costlier because we have to store the energy. For that, we have to purchase the power, and 20% losses will be there. As I already told you, for maintaining the thermal runaway, we have to maintain it at 25 degrees centigrade. Auxiliary consumption will be higher. So the net output will be having a higher cost for this battery energy storage system. But anyhow, there is no other go. Whenever you go for RE penetration more, then in that time you should have a battery energy storage system to manage the show in the grid. So RE integration challenges, if you take a massive integration, implies new challenges, intermittent nature due to a climatic condition. There is a limited control only over the amount of energy produced, because whatever the fuel, I am not having any control. But in our thermal plant, I am having a control over the fuel. I can feed the fuel, I can stop the boiler, I can put more fuel so that I can raise the load. But here it is not possible. I have to reduce my load by forgiving the harnessing the renewable energy. Large scale integration makes the imbalances in the electrical system management more difficult, becomes more difficult, as well as fluctuations at the produced power, as well as harmonics are also another important aspect. So the THD, total harmonic distortion, should be around less than 3%. It is because the power electronic conversion is happening. As I already told you, 2.5 megawatt inverters are used for the conversion of DC to AC. 1500 volts DC is the set of arrays from the solar PV modules. I get the power, I get the voltage to the inverter, and this 1500 volts DC is converted into around 600 volts AC, and this 600 volts AC is to be converted into 33 kV and then to 220 or 400 kV. So this is the process. So harmonics are inherently inbuilt. So THD value should be within 3%. And significant impact is the voltage variation and the overloads. So higher penetration rate means the greater the impact on power factor, reactive power, and harmonics felt by the grid network. So inappropriate penetration rate, it will have a harmful effect over the sudden losses of power, and eventually it will lead to total blackout. So higher penetration means properly we have to protect it by having battery energy storage systems. Or we should have some other arrangements. What are the other arrangements we should have? This is the solar intermittency. You can see the how it is getting fluctuated, due to which the voltage fluctuation in the red color it is shown, and due to which the transformers, power transformers, tap changing has to be operated frequently so that we can maintain the voltage profile. So this type of intermittency is one of the main challenge. So there is one way we are recently it has come into picture, is the forecasting, scheduling, and deviation settlement mechanism. So this is one of the method. Now it is being followed by our national grid. All the grid operators are doing it like this, and they are asking all the solar power plant people, including the wind people, to give their schedule. What is your generation? You have to give us. You have to forecast it one day before, and you have to tell what is the generation for each and every time blocks. So for that, one qualified coordination agency should be appointed for each power plant, and this agency has to make the modeling of the energy generation potential on seasonal time scales with the impact surfaces, and they should have the tools to visualize energy generation potential in the climate space. There is a long-term changes in the sun and its effect on earth. All these things are to be studied and the tools are to be developed and it's to be incorporated in the forecasting. Appropriate accuracy levels in the forecasting and scheduling are required and it's to be done by the QCA, that's a qualified coordinating agency. And if any, whatever the schedule, whatever the thing, this much is the megawatt that can be produced from this solar project. If any deviation from this value, the real-time value, then it will be penalized. So this is the latest development. And in the last 2 years, it is in the trial stage. It is being implemented. Wherein our role, our research scholars, our further study is having a big role in it. So this QCA responsibilities are renewable resource analysts, they should be, and they should have a modeling statisticians and softwares are to be developed for it. And 25/7 operation monitoring team should be available. Energy model are to be developed and separate schedules are to be declared. We have to declare the available capacity of the solar power generating station or wind power generating station. What is the schedule we have to give? We have to establish the protocol with the grid center, load dispatch center, communication with the particular protocol you have to make. And curtailment, if any curtailment is there, and it should be implemented. If any curtailment, if they say from the grid center, immediately we have to make. Any revisions in the due to curtailment will be given 1 hour before. There is 4 time blocks. One time block is 15 minutes. So 4 time block means 1 hour before the curtailment will be given, order will be given by the load dispatch center. So the solar power generator has to curtail its power. If the requirement comes, the revision will be implemented in the first, in the after four time blocks. So this type of arrangements, new arrangements are come into picture, and this type of schedule is to be given in 15 minutes time block, 96 blocks in a day. In each time block, 50, 0, 0 to 0, 15, 15 to 30. Likewise, what is the available capacity in the next day? There is a day ahead. What is the available capacity we have to tell? And we have to forecast for the solar power plant. What is the value we are going to supply to the grid? That we have to give it in a day in advance. Suppose in the plant we want to make a revision. The revision shall be effective from the 4th time block. When we are running the plant, some failure is there. Some solar PV modules failed, or some cable failure, or some transformer failure, inverter failure if it is there. So you can make the revisions, and revisions are to be submitted from the 4th time block, and the maximum of 16 revisions can be given in a day. That is 1 hour before. If we make a revision now, after 1 hour only, the revision can be implemented. So the currently available revised capacity and the current schedule are to be given in a revised schedule to the grid. The real-time data through telemetry, through IEC protocol, IEC 104 protocol, we have to give it to the state load dispatch centers. The solar generation, inverter-wise, how much, what is the megawatt, what is the megawatt, what is the voltage at the interconnection point, and the generators or inverters which are in the on and off, that also we have to give. And the GHI value, what is the irradiation value available at that site, ambient temperature, diffuse irradiation, direct irradiation, sunrise and sunset timings are also to be given to them, and cloud cover are to be given, rainfall, relative humidity, performance ratio. All these data are to be given from each and every site to the load dispatch center, so that from their side also they will assess, they will find out, so that the grid parameters will be maintained according to this real-time data. The deviation settlement mechanism, once in a month, the values will be taken. Suppose the available capacity is 2,500, schedule you had given 2,500 megawatt, but you had injected only 2,300, means 200 is the deviation minus So it is around 8%. At the rate of annual purchase rate of 2 rupees 57 paise, the penalty will be given. So 515 rupees will be the penalty for that generator for that day. So likewise, if you have more injection, like 2,500 instead, you are injecting more, 2,750, 250 is the extra. So it will be added as a positive value. So all these values will be deviation settlement mechanism. Once the month it will be done and the billing will be taken care. So this is the prevailing practice which is being used in our load dispatch sensor in our country. So this needs to be more improved by solar forecasting. So major challenge is the solar variability. Factors like weather conditions, cloud cover, time of the day are to be studied. How best we can use the latest technology. Solar forecasting methods, statistical methods, weather data obtained from the satellites and ground bases. These are the traditional methods. These are having the precision is less, and especially predicting short-term fluctuation is becoming difficult in this type of traditional methods. So it is becoming a very criticality for the grid stability and the energy trading. The traditional method, the persistent forecasting, assuming tomorrow solar output, the forecast will be done, and the major margin, the margin error will be around 20% to 50% sometimes. So lack of accuracy, it leads to inefficiency. This is a challenge. And the energy storage systems will also be underutilized, and the overloading of the grid will be there. So how to solve it? Latest method is we have to go for AI powered forecasting. That is artificial intelligence powered forecasting methods to get an accurate and efficient predictive framework to achieve the grid reliability and the efficiency. It will reduce the operating reserves capacity. It will be very much helpful. So people working in that field have to look after this AI powered solar forecasting using machine learning algorithms. We have to train up on the large data sets, because for the last 10 years, whatever the plants which is in operation, a large data set is available, and from the entire country, historical solar output data will be taken, and the performance of the solar panels over the time, because solar panels are also getting degraded when it is getting exposed more and more. So varying conditions are to be incorporated in the algorithms, and the weather data, temperature, humidity, and cloud coverage, all these data, and the satellite images and ground stations are to be taken care in the forecasting. And the latest, many people from many universities are making more work on it, AI-powered solar forecasting using the machine learning algorithms. By using the historical solar output data, weather data, and real-time satellite imagery, and using the deep learning techniques and the neural networks, it is being brought out. So many outputs are coming out now. It recognizes the patterns and make the sense of the complex interactions between the various factors affecting the solar production. And AI can predict how clouds will move, how much sunlight will be blocked, and to that particular solar power plant, it will be studied and it can be used. And it will be providing us a granular forecast, not a broadcast forecast. It will be giving an exact granular level for few minutes in advance to days ahead. Also, it is possible. So these are the AI-powered solar forecasting, which is coming. The leading companies, AI-powered companies, Google DeepMind is one of the main company which forecasts, accurate forecasting they are giving, optimize the energy consumption, reduce the cost. And ClimaVision is another one, AI-driven solar forecast to improve energy management. SunPower, they integrate the solar forecasting tools across its installations. QoS Energy, and also energy. Also energy is one of the global leader in the AI-driven forecasting, and it gives a better performance analytics and the operational insights for the solar power plant. Algorithms wise, we can say machine learning algorithms are mainly used. Artificial neural network inspired by the human brain only, that is a neuron used to recognize the patterns, learn from the data, and make the predictions. Support vector machine, let's say SVM. In machine learning, we have the three categories. You know already, there is a supervised learning, unsupervised learning, and semi-supervised learning. SVM is a supervised learning algorithm which classifies the data into two groups, and this classification also people practice, and this is also another algorithm which is used. Then decision tree classifier for short-term accuracies it is used. Evolutionary computing, reliable and improved predictions are made. Batch normalization. This method is used to make the training of the neural networks faster, artificial neural network faster. So these are some of the algorithms which is being tried by the research scholars. This is for our study purpose only, not yet come into the implementation stage. And other algorithms that are supporting the machine learning algorithms are fuzzy logics, adaptive neuro-fuzzy inference systems, expert systems, hybrid models, K nearest neighbor, KNN, ML technique with the SVM. By combining all these things also, we can make other algorithms so that this solar forecasting could be possible. Accurate solar forecasting could be possible. So the independent system operator who is having the AI powered solar forecasting will be having an information flow with the producers, and smart grid in which the consumer, prosumer, and the producer will be getting combined. And this independent system will be making the show. AI powered forecasting will be making the show with respect to the requirement. So GHI supply forecasting will be done. Then sampling frequency will be done. Pre-processing, deep learning, and post-processing will be done by the AI forecaster forecasting system. Then minute ahead, hour ahead, or day ahead values will be arrived in the forecasting, and cross validation will be done, and benchmark values will be checked, and the confidence interval will be arrived. So these are there is a performance evaluation of the ML algorithm is done. So by this, the AI forecasting is the latest smart power system which is being introduced for our people, and people can try more. And a large data set is available in India, so it can be utilized for our future growth. With this one, I want to conclude my session. Any questions you can please.
Thank you, Ramit sir. So dear participants, you can unmute your mic and ask the questions. Sir, they are thanking you for your presentation. In the chat box, they are putting the messages, sir.
Later on also they can contact you through you. They can send you, because from the research side, from the academic side, we want more interaction. Industry interaction is required. So let them send it. Okay.
Okay, sir. So you please send your contact addresses and some important materials to us, sir. I'll share in the group.
Yes, madam. Yes.
Okay, sir. Thank you, sir.
Thank you.
So, dear sir, on behalf of the organizing committee and the participants, our heartfelt gratitude to you for the for your enlightening session on solar technology and energy storage. Your extensive experience and insights have provided us with a deeper understanding of the advancement and challenges in this critical field. Your dedication to renewable energy serves as an inspiration to us all, highlighting the importance of sustainable solutions for our future. We are truly appreciative of the time and effort you have invested in sharing your knowledge with us, sir. Thank you very much, sir, for your invaluable contribution to our program. Thank you very much,
Thank
sir.
you. Thank you, madam. Thank you.
Thank you, sir. Thank you, sir. Sir,
Good afternoon, ma'am.
good afternoon, sir. Sir, shall we start the session, sir?
Sure.
Thank you,
Let me
sir.
share my screen.
Yes. Okay, sir. Good afternoon, everyone. So now it's my pleasure to introduce our distinguished speaker of this session, Dr. Sarin C.R. Dr. Sarin C.R. is an accomplished learning and development leader, educator, and data science expert, currently serving as associate lead L&D at Quantipi. With a PhD in data science for power system automation from Belur Institute of Technology, he has a strong foundation in AI-driven learning methodologies, business analytics, and power systems automation. His diverse academic background includes an MTech in mechatronics engineering, an MBA in human resource management, and a BE in electrical and electronics engineering, reflecting his multidisciplinary expertise in both technology and leadership. With over a decade of experience spanning academia, corporate training, and industry consultation, Dr. Sarin has worked in key roles such as academic manager and SME at Miles Education, assistant professor at Bimal Jyoti Engineering College, and CHRO and solution architect at Saints Agrotech. Throughout his career, he has delivered lectures in more than 100 workshops and training sessions on embedded systems, artificial intelligence, cross-platform app development, and STEM education, catering to a wide audience from students to corporate professionals. Dr. Sarin specializes in corporate training, executive coaching, business analytics, leadership development, and human resources management, implementing modern L&D frameworks like micro-learning, and project-based learning. His expertise extends to blended learning techniques, flipped classrooms, and digital transformation strategies for education and corporate sectors. A certified data analyst, and career counselor, he has completed more than 45 professional courses and multiple specializations from prestigious global institutions. In addition to his teaching and training expertise, Dr. Sarin has a strong research background in data science applications for power systems and has contributed to multiple academic journals and research projects. His technical skills include programming, data mining, AI-driven analytics, and Microsoft Power BI, making him a valuable asset in bridging technology, education, and business analytics. Passionate about innovation, learning, and knowledge sharing, he continues to explore new frontiers in L&D, AI-driven education, and industry-driven learning solutions. So we are very much thankful to you, sir, for accepting to deliver a session here. So now we welcome Dr. Sarin to this FDP. Welcome, sir.
Thank you, ma'am. Thank you very much. Good afternoon, all. Let me start my session. So I'm planning to have a quick introduction about some of the research areas currently which is trending over green energy as well as sustainable solutions for the future. So rather than explaining some technical terms, I would like to more focus over what are all the research trend which is happening over these areas. And when we are checking about green energy, sustainable solution, and many more areas, See, it's a very large area. A lot of research are going over different domains and everything. So I was just going through the conference plan and everything. So what I understand is that there are some areas which is already covered. So I'm not getting into those particular areas. Instead, I would like to share some insights primarily from industry-wide or finance-wide or solution-wide, where there is a lot of research going on, and how we can incorporate our new research topic to that, publish some good papers over those particular areas, identify some niche areas. Okay, so I'll quickly move to the topic. Just as an introduction, I don't think we need to explain this, because as we know, there's a huge demand for the energy all over the world, right? And if we just take the average increase in the demand, it is just 3.4 percentage. Whereas if we just take the average increase in the percentage of new energy installation and everything, it is nearly 11 to 12 percentage. So the energy installations are more when compared to the demand. Still, many people are, or many organizations or many areas are still struggling to find the uh, meet the demand. This is mainly because even now, nearly 80% of the world's energy supply, it is done primarily using fossil fuels. So even though there are a lot of trends coming over installation of solar photovoltaic cells, coal, wind energy, and many more technologies, still the major contributor is 80% of the overall energy. It is from fossil fuels. So if we just check over the industry, most of the research is going on over these areas where we are trying to reduce the use of fossil fuel related technologies or those kind of things, and increase renewable energy sectors. But at the same time, there is one more problem which many people are facing. If we just check with the most of the research papers over energy sector, nearly 80 to 90 percentage, I could say, it is more focusing over the technological side, how we can solve a technical problem. But apart from that, there are more problems which is unexplored. I'm not saying that it is completely unexplored. I know a lot of people working over these domains. Even one of my close friend, his primary domain is energy pricing and everything. But I'm saying that many people are not that much involved within these areas. Still, even though there is a lot of technologies, a lot of installation and everything, even though electricity power is freely available, nearly 1.8 billion people are not using electricity, mainly because of the cost and everything. Especially in Africa, nearly 447 million people who do not use electricity despite being electrified. So you know, their houses are electrified, but they are not using. That is why, if we just stick with the sustainable development goals within United States, which was released, as well as which is supported by World Bank too and many other financial institutions, one of the primary problem is not the availability of energy resources or something like that, but the price and affordability and everything. So one area in which there is a lot of research going on, and which is figuratively little explored within India, but in many other countries it have been highly explored, is the uh, cost benefit analysis or costing of electricity related areas. Due to the cost or the cost of the production, many people are still not able to use electricity even though they have. For India, it is not a problem because we are having one of the cheapest energy available. So many people are not exploring these areas. But this is one area where we can explore. A lot of research papers are going over this area. Now, as the implementation of different AI technologies and everything, I know a lot of organizations which run millions of rupees for these areas to find a sustainable, economically sustainable energy solution. Now, let me address one problem here. See, I'm not taking a criticism, but when it comes to India, when we are trying to publish some papers, or I'm not talking about everyone, there are many people who are genuinely taking these kind of things. But some people, what they'll be doing is they will first find a easy solution, easy result, then they will try to write a paper over that, because many of us are, even when I was working over many institutions and everything, we are primarily making papers because we need to show it either in our resume or National Board of Accreditation visit or an NAC visit or similar related areas. If you just check with the outside, if you just check with United States or Europe or some other areas, you may have noticed is that when we are completing a PhD from there, we are easily absorbed to the industries. But when it comes to India, if a PhD person applies to the industry, in many cases, then sometimes it may not be accepted. Because one problem, which actually I'm primarily working over human resource domain. So we used to interact with a lot of HR regarding recruiting and everything, even regarding research and everything. So whenever whenever I'm interacting with them, one feedback which I'm getting is that our primary way of implementing the research methodology is not industry related, rather solution related. We'll be always trying to find a unique solution. Then we will try to find a some unique methodology to solve that particular problem. Then publish a paper on that. Whereas industry, it is not always hunting for a unique solution. Rather, how we can address a problem with more cost effective or a better way, even though that particular technology have been used for years of you know publications and everything, still industry is providing more relevance to that particular area. And there is a lot of it doesn't mean that you see, if I'm using a existing technology which is not a niche area, whether my paper will be accepted or not, it doesn't matter. Many papers are easily getting accepted. So this area I would like to explore, where rather than going for some technical terms or jargons or something, where we can find some good areas which is more relevant to the industry, which should be more easy, so that suppose we have a good number of papers, we can easily even absorb or interact with industry, then work or get some grants or something with the help of some industry, or even migrate our job to an industry level research and development. One more thing, yeah, climate change and everything. So I don't need to explain why sustainable and green energy is required. Instead, I will be explaining some areas where more number of research are nowadays going on, which is industry relevant, not just technical. Okay. Now, coming back to the topic. Yeah. So primarily, the renewable energy sector is highly supported by solar, wind, battery, and nuclear, and many other energy sources are also supporting. But interestingly, you may have noticed is that the contribution of wind energy is decreased. Within last 1 year, the contribution of wind energy has fallen nearly 14%. It's mainly because the cost related things. The point I want to make is that, see, when we are publishing something, we may be more focusing over the niche area. Instead, there are some areas where industry is facing a lot of struggle, especially within wind energy. In solar energy, there is a lot of research going on, but when it comes to wind energy, making it cost effective and increasing the yield and everything, there is a lot of funding going on. So you don't have to always go to DST or some other organization to get the funding. Even if you could provide a good solution, if you identify organizations working over these kind of areas, and if you could find a good solution and submit to them, they are ready to pay. They are ready to pay a lot of amount of money. I know many organizations which is primarily in NARF ranking the top, they are submitting their project to the industries, then they are working on different projects. Okay, the point I want to make is we are not expecting a equal momentum over all renewable energy technologies. There are reduction in some technologies in past few years, which was a trending technology. See, I still remember 2015-16, I have published 1 to 2 papers over wind energy, because at that time it was a trending one. But now many organizations are reducing its investments over wind energy. And you may have noticed some of the major electricity based companies, their shares are getting reduced mainly because of these kind of problems. So when we are saying that renewable energy will be creating a sustainable future. We need to also identify which renewable energy and what is the momentum and over which level it will be implemented and over which area, because every technology sometimes they may be useful in one area, they may not be always available in other areas. For an example, solar energy, it's plenty in India, but many European nations, solar energy is not a primary source of power generation, mainly because of the they are having some long spring or something, so solar may not be producing that much good energy. So these kind of problems will be there. So yeah, this is the one. Second, uh, another set of projections where many industries are working for finding solution and doing a lot of research is new demand areas. So even it was a new information for me when I first heard of this nearly 6 to 7 months before. Uh, Traditionally, we'll be thinking that demand will be mostly generated within electric vehicles. There will be demand generated, or manufacturing unit there will be demand generated, or household there will be demand generated. But there are new areas where higher amount of demands have been generated in fewer areas, which is not a very common area. One of which is data centers. Data centers, in short, we are all using chat gpt and related tools. Like some will be using Microsoft Copilot, some will be using chat gpt, some will be using Google Gemini and many other technologies, right? For facilitating these kind of technologies, we need to accommodate large data centers as well as computing system. And when you're when you're typing some simple query within ChatGPT, that particular query is sent to a remote location which where data centers will be implemented, and they are using an enormous amount of computing power to make the decision. For now, they are not asking you payment or something. Instead, they are making their own investment. But many organizations are spending billions of rupees for data centers. You may have heard that DeepSeek. Why DeepSeek is so much taken momentum and everything? Because they are helping you to create a result with minimum data centers. That's only criteria with DeepSeek, China's DeepSeek. There is only one item which is making DeepSeek the better. It will be using less data center powers. That's all. Nothing much when compared to ChatGPT or many other models. So you may have noticed the amount of energy used over DeepSeek, which is much greater than the entire energy which have been used within South Africa. So South Africa's annual energy budget is less than the overall energy spent over the data centers, or Egypt or many other countries. So enormous power of energy is being used there, and in future also many data centers and related tools will be coming, and new demand centers will be generated. And when we are finding demand response algorithms methods, or we are writing some papers over those kind of areas, we'll be mostly addressing industrial loads or related tools, or even household and everything. The usage pattern for industrial loads or household consumers and data centers are extremely different. So nowadays, many organizations are funding a lot of amount of money for doing some research within the data center, how we can optimize the data center usage, how we can optimize the power usage within data center, what are all the methodologies available. And these areas, there is a lot of research going on. Okay, so from now onwards, my primarily focus will be these 5 points. One, industry policy goals rather than going to very technical side. Renewable energy, how we can scale. Long duration energy storage, where we can, which is also a trend. Let me explain one by one. I'm just getting into that. Okay. Yeah. So the point I want to make up to this point is that there are new niches of, or new areas of research which is developing within last 2 to 3 years. And if you could find a good solution over these areas, one, you'll be getting a lot of funding. Second, uh, obviously the research publication and everything, it is highly promoted. Third, it will be easy for you to either migrate to industry or get in touch with the industry with latest technologies and everything. So what I have done, I have identified some 7 to 8 areas where industry is going behind. One is obviously green hydrogen. I don't think I need to explain that. So we can use hydrogen as a fuel. So what we'll be doing, we'll be creating hydrogen by splitting H2O, water and uh, from water we know we have hydrogen and oxygen. So we can split the water and create hydrogen. And one advantage is that hydrogen, it has very high energy density and it's a clean fuel. So nowadays, many organizations are moving to development of green hydrogen technology and how we can make use of it. Second is long duration energy storage. There are different methodologies available where industries are trying to store the energy for longer duration of time when compared to the uh, existing batteries and everything. If you remember, there was a time when we used to charge mobile on daily basis multiple times and everything. Nowadays, many batteries are reaching for 3 to 4 days, right? So these kind of technologies are more coming to the mobile phones and related areas, but industry is spending a lot of amount to make it scalable for large world. It doesn't mean that when it comes to long duration energy storage, it be only based on batteries. There are many other mechanical methods too, which if time permits, I'll be discussing. Then advanced solar technology. One of the major problems with solar engineering related technology is that its efficiency is comparatively very, very low. So there is a lot of technology implementing over solar panels. Perovskites, solar panels, trending technology. There is a lot of research going on within the chemical, chemistry related areas or material science related areas. Then there are bifacial panels, which will be uh, extracting energy not only from the direct sunlight but also from the reflecting sunlight from the Earth's surface and everything. Then there are thin film panels, which will reduce the size of solar panel so that it can be accommodated within cars or moving objects and everything, which can extract energy. So there is a lot of research have been going over those areas. Then even creation of organic solar cells. Then transparent solar cells. Okay, suppose if you could create transparent solar cells, all the uh, you know uh, the windows and doors of our different buildings can be replaced, and it will create a revolution in those particular areas. And also solar battery storage. Now some people, I'm not talking about everyone, but some people will be thinking that yeah, these kind of technologies, it may be done with a very large labs with a load of funding and everything, whether we can afford on that, whether we can work on that. No, it's not like that. Within our organization, I know within South India itself, many people are working over these areas, and they are purchasing the chemicals, they are working on it, they are creating new solar cells or the technologies, that they are doing analysis. And many of our central government labs, they will help you to research over those areas. So what you can do is, suppose you may be working with one organization, you could write a mail to that particular research lab, and you could ask them, see, I have developed this kind of particular product, but I need to check that particular product. Can I have some slots? So you can send a letter with the with signed from your head of the department or head of the institution, and these central government labs, they will help you to test these kind of technologies either free of cost or with minimum amount of cost, very less amount of cost, just for the cleaning and some security deposit and everything, a few thousands only. And the thing is that, to be honest with you, the number of research which is going on within India, it's comparatively very, very less. Mainly because many people are thinking that it's very difficult to do, or centers are not available, or doing things are difficult. But there is a lot of research going on, and many IITs, IIScs, they are providing some more like a boot camp. You could just check with their website, and suppose you have been selected within that particular boot camp, The cost and everything will be handled by either central government laboratories or these IITs and IACs. Okay, we can make use of that. Now, enhanced geothermal system. Again, the research over enhanced geothermal, even geothermal systems within India is comparatively very, very less. Whereas in many areas, even Europe, it is used a lot. We have a lot of options available to work on it. Now you'll be thinking that how we can work over these kind of things, it will be very difficult and everything. No, if you just look around, you'll be finding a lot of people who is working over these kind of areas. It doesn't mean that when it comes to geothermal systems, we need to go very deep. Then we need to create a systems and everything. It's not like that. There are many feasibility studies and many energy organizations are paying a lot of amount of money for doing research. Not just money, but they will also provide some equipments and everything. All you have to do is you need to do the systematic research and everything. Now you'll be wondering why industries have to select us for these kind of tasks, why they can hire a person. See, I will tell you one example which one of my friend HR has recently told me. So his organization has roots in Europe as well as US. Suppose, see, he has some data. Okay, that particular data include a lot of information. Now all he need to do is he need a person, he need a research scholar to analyze the data and publish a research paper. Suppose he is giving this particular data to a research scholar who is residing within Germany, where his company primarily operates. He need to spend nearly 5 lakh to 7 lakh rupees, or even minimum 3 lakh to 7 lakh rupees per month. Whereas within India, we can do the same task within some 50,000 or 60,000 rupees per month, which is just 1/10 of the overall cost. So many organizations which are working over Europe or US or even Middle East, they are looking for people who can take care of these kind of tasks, freelance research options. So if you could correctly identify those people and you could submit a proposal to them, those kind of companies, you will be able to get some good research funding, as well as sometimes you'll be even able to get some good research jobs also within the industry itself. Now, how to find it? Very simple. 2 areas which I suggest. Go to LinkedIn, search for it. Whenever we are adding some LinkedIn searching, sometimes we'll be limiting that to India only. Make worldwide research over LinkedIn, and you'll be finding a lot of researchers are looking for research fellows. Just make some connections with them, apply for it. They will be accepting. Don't worry. Some people will be thinking that if I am just sending a request, what will they think? Whether they'll be accepting me or not? Don't worry about that. Just send a request. Ask directly. One good thing with Europeans is that they will always talk to everyone, whether it is from India or some other place. Then they will be checking with you, and if they found that you have some good knowledge and everything, they will easily provide you support. Now, second, smart grids and grid modernization. A lot of technologies have been implemented here, primarily Gen A, which I will discuss later. So we all use ChatGPT, right? ChatGPT related tools. How many papers you have seen where ChatGPT is used for grid management or grid optimization and everything? I just searched over internet and I found that very few papers within India where electrical engineers are more interested within using cloud related tools or these kind of related tools and publishing papers. Whereas when it comes to the Europe or many other areas, a lot of papers are publishing. And if you just check with the overall momentum, nearly 70 to 80% of the papers over these areas have been published within last 2 to 3 years. That means there is a lot of acceptance. Think about it. Now, I would like to add one more comment over this. See, one one common thing which I have seen is that suppose I want to build a paper. My HOD is saying that you should publish a paper within next 2 months. What I'll be doing is there is a very common simulation tool are, I was basically from electrical engineering, so I don't want to name that particular tool, but there is a common simulation tool available with, or I mean, within electrical domain. It is being only used within instrumentation domain or even mechanical engineering itself, but there is a very common simulation tool available within electrical domain. We will create some configuration over that particular simulation tool. Then easily within 2 to 3 days itself, sometimes we'll be able to create a new paper. But if you just check with internet, how many organizations in industry wide that particular simulation tool is being used, you'll be surprised. Less than 50,000 organizations all around the world is using that particular simulation tool. But if you check with academics, okay, I assure you, nearly 99.99% of the universities, colleges, technical institutes, they will be teaching different technologies to the students using that particular simulation tool. I don't want to name that particular tool. The point I want to make is many things which we are using within our departments or technology, they are not industry relevant. Whereas if you just check one technology, okay, which is called as cloud computing. Now, some people will be think that cloud computing is related to computer science. Okay, just check how many organizations or how many top organizations are using cloud computing for their daily activities. I assure you, nearly 99.99999%. But how many electrical staffs know cloud computing? I could say not even 10% or not even 5%. Cloud computing is more important than this particular simulation tool. And many people will be there learning cloud computing or learning the tools within cloud computing is very difficult. No, it's very simple, very, very simple. And there is a lot of research opportunities. Why? Because cloud computing is mostly handled by computer science engineers. And there is a lot of electrical or electronics or mechanical related problems that can be solved using cloud computing. Electrical or mechanical or instrumentation engineers does not know cloud computing. Computer science people does not know mechanical, electrical or electronics. So there is a gap between these two people. Just because of that, many solutions are not available. I'm talking about India. Whereas if you just go to Europe or many other organizations, a lot of publications are going over these kind of areas. So if you could learn cloud related technologies and how it is being used, there is a lot of YouTube videos are available, or even if you just stick with the cloud leaders, one of the most commonly used cloud technologies, AWS, Amazon Web Services, they have a lot of free training programs. You could enroll to that particular training program and they will teach you. And many problems within cloud computing, many problems with the electrical, electronics, as well as mechanical engineering that can be solved using cloud computing related areas. I primarily working over an AI-driven organization where nearly 99.99% of the operations are done within the cloud itself. So my primary duty current days is that making people train for cloud certifications. When I'm teaching that, then I realized that some items which I have done when I was doing our research over electrical engineering domain, the same items which I have done with 3 months, 5 months, or 6 months, the same item, if I know cloud, I could have done that within 3 days or 2 days or even 3 hours. So the point I want to make is that try to identify industry domains and what technology they are using. And if you could bring that technology to the academic level, you could easily publish a lot of papers, as well as you could easily interact with the cloud, and you could also bring the benchmark of your students to the industry grade. The point I want to make is over these areas, sustainable, smart grid and everything, there is a lot of technologies which is happening within industry. I will discuss that later, but I just want to give an introduction. Now, carbon capture and storage. It's one of the trending topic. Even I don't know how many of you know or not. Within India, there are some 20 districts have been selected all over India, and government is giving a lot of funding to make that 20 district carbon neutral. Carbon neutral. That means emissions are emissions of carbon dioxide and related tools are less than that of what the renewable energy related things which they are making and everything. Now they want to expand that to 50 states and everything. I mean, 50 districts and everything. A lot of fundings and research are going on this area, not only within India, but also abroad. One thing is that carbon capture and storage. I think most of you are aware about the duck curve. Just give me a second. There is a condition which is happening with developing countries, which is primarily called as duck curve. It is very simple. See, during daytime, nearly some 12 o'clock or 1 o'clock, the solar energy production will be exceeding the demand. So there will be higher production when compared to the demand. So what will happen? This extra energy, either we can store that within, within battery storage system or inverter or something. But what is the problem? You may have noticed nowadays current the electricity supply is more like very stable. So we may not be using the electricity supply continuously for a while, right? I mean, inverters continuously for a while. So there will be still excess power. Now, in many organizations or many developing countries or even developed countries, what they are doing, they are using this excess energy to split carbon dioxide to some other format, or converting carbon dioxide to some other format. Okay, so what is happening? There are excess solar energy which is unused. That excess solar energy which is lost without using it, they are using that particular energy for converting carbon dioxide or related tools to some other format, some other chemical form, so that it will not create emissions. And a lot of research is going on. When I was searching, I could find that there are less number of papers which is from India over these particular topics. But if you just check our internet, you'll be finding a lot of research is going on, primarily within US and some developing countries within Scandinavia, because they are more interested in spending money over these kind of things. One advantage is that it is very, suppose you have some good number of publications within next 1 year, it is very easy so that you can migrate over some projects which is working over Sweden or Scandinavian countries, where these kind of research is getting some good momentum. Again, one more area where a lot of research is going on. I don't think I need to explain about that, so I'm skipping at that point. Electric vehicles and solar. Okay, solar. Now there is small, good amount of research is also going on creating small modular nuclear reactors, but we may not be able to directly work over it because a lot of funding and everything is needed. But still, many organizations working over these areas looking for data analysts or data interpreters. So we cannot hire a person who is working within the computer science domain for these kind of activities. Why? Because it is not just about analyzing data. Unless that particular person have some good knowledge over what is the data he or she is processing, what is the electrical terms, what is the technology used behind that, or what is the mechanical, say a steam turbine is used, what is the concept behind steam turbine and everything, and how it is working, they may not be able to create a proper report. So we'll be thinking that, or some people will be thinking that when it comes to data analysis, it will be purely focusing over computer science people only. No, it's not like that. If we want to analyze a data from steam turbine, we need a mechanical engineer who knows computer science, how to analyze data, or a computer science people who know how to analyze a mechanical, some thermodynamics principles and everything, which is very difficult. So I know when I used to interact with HRs, they are saying that uh, rather than a computer science person learning mechanical related things, many mechanical, they are hiring people from the mechanical department, then they are training them over data analytical related operations. Okay, so there is a lot of opportunities which is going over the research and everything. You could make use of it. Now, one unexplored area where there is a lot of research is going on is green hydrogen. Okay, I have just added a red color item here where you could see nearly 1 out of 8 papers over these areas, green hydrogen related papers is published within last 2 years. That means there is a higher acceptance for papers published over these areas. Plus, there is a lot of research going on these areas. Now we'll be thinking that working over hydrogen and everything, it may be a bit difficult because we don't have facilities and everything. Don't worry, there are many organizations who is searching for research fellows over these areas from industries. Okay, so for industries, they'll be providing you all technical facilities and everything, but they may need a person who can do the structured research over these areas. And when it comes to green hydrogen, it doesn't mean that every research is done in a single area. No. For an example, the development of alkaline electrolyzers, which is very important for the green hydrogen. For doing this particular research, we don't need a large facilities and everything. Many of our universities, they are doing within their labs itself, chemistry labs itself. Proton exchange membrane electrolyzers. See, we all know we are primarily using platinum for splitting oxygen and hydrogen as a catalyst, which is very costly. So nowadays, a lot of research are going on proton exchange membrane development over the chemistry side. And one problem which mechanical engineers can solve over this area, I will tell you. See, now again, when it comes to chemistry people, chemistry professors, they know how to work over the chemical things, how to do the combination, materials developments and everything. But in many areas, they need to build some mechanical equipments to solve this problem, or some electrical equipments to solve this particular problem. They may not be able to do it because they are not expert within building products and everything. So I know a lot of people who is struggling to create machines for completing their chemistry research. So if you could identify, suppose you are working in an engineering college over over mechanical department, or an electrical department, or an even electronics department. I know. See, 2 to 3 persons have contacted me, and they are contacting me for a while. They want to create some sensors and everything, which is more related to chemistry. So they know the technology behind the chemical parts and everything, but they don't know how to build it. And for that, they need an electrical engineer or an electronic engineer. So if you could find niche areas within these area where you could work with a chemistry professor, there is a lot of research going on. Chemistry people does not know mechanical part. Mechanical people does not know chemistry part. If you could join together, you could create a lot of good research papers and also a lot of funding. Just check with that if you are interested. And yeah, now one more thing where a lot of research is going on over renewable energy sector. See, if you want to split hydrogen from water to oxygen as well as hydrogen, then you need to provide a lot of energy. And currently what we are doing is we are making use of renewable energy to split oxygen to hydrogen, then storing hydrogen for later. For example, say I have a solar panel, and during afternoon time for 2 to 3 hours, where my demand is less than what energy is produced by solar panel. So that excess energy I can make use for creating hydrogen. A lot of research is going over these areas, how we can optimize how we can schedule these renewable energy sources for creating hydrogen. I will just explain it later. There is a special terminology which is used. I will explain later, but I just want to add. Now, here you could see hydrogen compression, right? I know one person who is doing research over hydrogen fuel, but he's deeply in need of a mechanical engineer to work over the compression portion, because he's not confident about how those things are working and everything. He's looking for a person. It was nearly some 6 to 7 months ago. Okay. The point I want to make is there are many areas where you could work together in a hybrid mode, where two different sectors can combine together and create extremely good papers, which can be accepted within top journals. I don't know whether you noticed or not. When it comes to physics, chemistry related areas, publications, just check with their good journals. Just check with the impact factor. It will be much higher than the impact factor of some regular technology journals. Okay, now one more point. I've just added a red color. See here, they may be working over chemical domain, and many cases they will be creating some results, but for analyzing that particular result, they may need a data analyst. Suppose you are working over computer science domain, you'll be thinking that what I can do with chemistry, there is nothing I can do with chemistry or something. No, it's not like that. Many chemical engineers or people who are doing with research within chemistry related areas within hydrogen fuels, they are looking for computer engineers for analyzing their data. And there is a new, actually it's not a new term. There is a very growing term which is called as chem informatics, which is combining chemistry with uh, this computer science related analytical and everything. Okay, now, yeah. Now let me go to some other parts where custom solutions or industries are more interested. One thing is that everyone knows that energy storage is the future. Okay, and there is a lot of investments going over energy storage. Out of that, one of the most prominent technology nowadays, it's lithium ion batteries. But we all know what is the main problem with the lithium. Lithium is, if you just check with the availability levels, the ranking for lithium when it comes to metals, it is 32. That means the availability of lithium is comparatively very less. And most of the lithium available, that's primarily taken it from this South American countries. Okay, this is creating a geopolitical situation. This is creating a lot of problem for many manufacturers. If you remember, there was a lot of wars within early 70s and 80s over oil in the Middle East. Most of the wars, the primary reason was oil. But nowadays, United States and many other organizations, they are fully equipped with their own production systems and everything. Now that tensions and everything has been primarily reduced. But still, there will be new wars coming over energy storage, primarily just because of lithium. So lithium will be next oil. We need lithium. It's inevitable to create batteries and everything. And the availability of lithium, it is decided with a lot of geopolitical situations. So nowadays, a lot of research is going over two areas. One, finding new sources of lithium. That's one area. Second, replacement of lithium. One replacement for lithium, yeah, it's called material bottleneck. Okay, primarily geopolitical and social impact is going on. For an example, just take one replacement for lithium, which is cobalt, and cobalt is used within a lot of batteries. Okay, nearly 70% of the cobalt is developed within Congo, Democratic Republic of Congo. And out of that, nearly 80% it is extracted with modern day slavery as well as with the warlords. If you have seen some African movies and everything, or movies related to Africa, you may be finding that there is a lot of warlord related things. Even child soldiers are present. A child of some 7-8 years of old, they may be provided with weapons and they will be asked to. It's mainly because almost every major global manufacturers, they are trying to get some deals within this warlords, get cobalt. So it is creating a lot of social impact. And see, sometimes within India, it may not be a big problem, but when it comes to Europe, if a particular company is purchasing something from a warlord within, within Congo or Africa, many people will be doing some good amount of campaigns against those people. You may have noticed is that there was a large campaign against a major luxury brand mobile phone manufacturer. I don't want to name them, but a luxury brand manufacture, due to which their sales have been reduced nearly 20%, mainly because there was a leakage of news saying that they are using child labels in Congo for creating cobalt for their mobile phone batteries. So these kind of problems are also there. So now many industries, they are trying to find a solution where if we can find alternative set of batteries or alternative metals for batteries. Now you'll be thinking that it's a very difficult areas to work. I'm talking this to especially mechanical engineers. If you are working over, if you are within this call, also with electrical engineers, you'll be thinking that creating a battery and doing a research, it may be very difficult. No, it's not like. Many organizations, if you just stick with around you, many universities within the chemistry department, they are doing research over these areas. And see, chemistry people, chemistry professors, they can create battery, but checking its optimization, creating circuit for analysis, and doing some instrumentation for the finding the battery SOC, the state of charge, the discharging pattern, and everything, will be doing it. Electrical engineers or people who are working over those domain need to do it. Not every chemistry people may be expert over these areas. So there is a lot of collaborative research is going over these areas where chemistry professors or research students, they are creating these kind of modules, but they need help of instrumentation engineers, electronic engineers, as well as electrical engineers to create solutions. So if you could find some niche areas over these areas, you could easily publish a paper, I assure you, because there is so much need. Okay. Yeah. Some people saying it is a hoax, but Elon Musk is trying to create a battery which replaces lithium with aluminum ion battery. And there are rumors that it's being developed, or there are other rumors that it's a hoax, but many people believe that it's a real story. But if it was involved, the entire energy problem all over the world related to the battery sector will be solved, because aluminum is one of the most commonly available metal. So there is a lot of research going on, and many industries are chasing behind that. And if you could find some battery manufacturers or manufacturing companies who is working over automobile domain or some related areas, you could make some agreement with them. You'll be easily getting some good funding for industrial research if you could do some good pitching. Because I know some organizations, they are struggling to find researchers to do these kind of tasks. Okay. Yeah, the point I want to make is these areas, there is a lot of research going on and you could make use of it. Now, one more most trending area, I have already discussed how it is working before, power to X. Power to X is that in many developing countries, as there is a lot of installations over the solar, during daytime, demand is much less than the production. So production is excess. And they are not able to store that to a battery, because the battery storage is very costly, and every battery has a life cycle. You can charge battery for some 500 times or 5,000 times or something like that. After that, every time you charge and discharge, the battery will be getting weak. So you may not be always able to use the battery. So nowadays there is a lot of research going on in which whenever there are excess power available, convert that excess power to some other form of energy, out of which one of the most common prominent one is H2, or there are some pumped storage systems also, and use this energy either to run equipments, okay, or reverse process, the making carbon dioxide, converting carbon dioxide to some other methodologies. Just search over internet, you'll be finding that how much number of papers have been published over these areas within the last couple of years. A lot. Okay. In conclusion, I want to add these kind of things. Okay. Now, when it comes, so far I have explained about the socio-technical constraints, But apart from that, when it comes to technical side, when it comes to a sustainable grid, a lot of research is going over these kind of areas. One, advanced metering instrument, simply smart meter. Okay, now some people will be thinking that, oh, smart meter, what is there to do? It is just a simple thing, right? No, it's not like that. Smart meters, if you just check with the that data coming with that data profile coming with the smart meters, you will be finding that most of the smart meters are designed to be operated for 20 years plus. Suppose electricity manufacturer is purchasing a smart meter and they are installing within the house. They are expecting that for another 20 years this particular smart meter will be working. It was the situation till some 5 years before, but you know how much change there have been developed within last 5 years, right, over the data analytics and artificial intelligence domain. Now many manufacturers, they are planning to create smart meters which can accommodate a artificial intelligence as well as data analytics. Now it will create a lot of problem. What is the problem? There will be two problems which will be facing. One, existing, there is a lot of smart meters are implemented. How we can integrate AI technologies with the legacy systems, which is very difficult. Second, suppose I'm creating a new smart meter and I'm distributing that to the consumer. Suppose I have created a smart meter today, distributed. Suppose tomorrow there is a new technology is coming. Okay, how I can accommodate that? How I can create a smart meter which can incorporate even future technologies which have been found in future. Okay, so many people will be thinking that say it's a very common area. Smart meter, every final year project or every final year mini project, if you go in electrical department, at least one student will be doing our smart meter research areas, or they'll be creating a smart meter with a current sensor, with a voltage sensor. It will be sent to a Arduino board, and Arduino board will be displaying it. They will do some relays or something like that. Okay, no, it's not like that. There is a lot of research going over this area, which primarily focusing over three areas. One, I told you, cost. Okay, if you want to integrate AI related things, it should be built cost optimized. So you should create a model which can run just like the DeepSeek, right? So what is the primary technology behind DeepSeek? It's nothing. It can even operate with very low volume of RAM capacity or computing capacity, right? The same way, if an electrical engineer, because only an electrical engineer may be able to do this because he knows the working on operations of electrical things. If he could create a model which can analyze electrical data with minimum amount of computing resources or minimum amount of this microcontroller requirements and everything, there is a lot of opportunities there. Second is that data privacy concerns. See, most of the development side, one problem is that they are very raw. So data can be easily extracted with, I know many uh, many smart meters, they are not encrypting the data. They are just displaying it correctly. So if you know where to connect within a microcontroller or where to program within the microcontroller, you could easily take the data. Yes, Monish. Monish, you're asking something. Monish, sir?
No, sir.
Okay, yeah. So privacy is a big issue. Second is that automation and control. Okay, many organization, they are going to automation. Okay, not only in the automation, just for a regular operations, but also for the entire grid operation. So whenever we are thinking about automation, we'll be mostly thinking about using some PLCs or related tools for doing that. No, it's not the case. I just want to ask you, I know most of you have heard of, but how many of you have heard of operators of ChatGPT? Operators of ChatGPT. Can you please raise hand? I just need a feedback. Operators within ChatGPT. Okay, as no one has raised hand, let me just show you. See, ChatGPT has released a tool which is called as operator. One second. Just give me a second. There is a tool called operator. I know some of you may have already heard of that, or you may be using it on daily basis. But what they are doing is that, see, currently I want to book a flight ticket. Okay, suppose I want to book a flight ticket. What I will be doing, I'll be going to make my trip or some other website. Then I'll be going there. Then I'll be searching for the flight from Delhi to Bangalore when it is available. Then I'll check with the, the pricing and everything. Based on that, I'll be booking it. This is a regular thing. Okay. Now, if you are using an operator, which is primarily called as AI agent, it is primarily called as AI agent. If you just check with the operator, you'll be seeing that I want to book a flight from Bangalore to Delhi. Okay. Now, what operator will be doing? It will first go to your calendar and it will find when you are visiting the Bangalore. Okay, or when you are visiting Delhi. Then from the calendar, it will check within different websites when flights are available, and it will also find, suppose in Bangalore, say you need to reach there 9 o'clock in the morning, then the operator will automatically check whether you need to join the 9 o'clock or 10 o'clock. Based on that, it will also find the hotel. It will also find the taxi where you can move from hotel to taxi. I mean hotel to that particular conference or some location. Based on that, it will also find the flights. It will also find how we can reach from uh, airport to hotel. So it will find a good plan for all these things. It will even book for that. That is what operator will be doing. So think about a situation. Nowadays, all these operation I need to do, right? So now what all I need to do is I'll be just saying that I want to go to Bangalore. Then it will automatically check. Then it will find a good plan for us. Then it will first check with us, okay, whether this is a good plan for us or not. If it is okay, whenever I'm saying yes, the rest of the operation which will be done by the operator itself or AI agent itself. Now, some people will be thinking that, oh, it's a fancy story. No, it's not a fancy story. One second. Actually, there was a website. I just forgot that. Just give me a second. Okay, there are some website which is already providing these kind of service, though it is not that much accurate. Okay, now, okay, it is there. What is the use for us within electrical or mechanical or sustainable energy domain? Think about a situation in future, there will be AI agents which will be automating the grid operation. It will be automatically collecting data, who are all using what type of energy, how much energy is needed, uh, where is the loss is coming, how much projections are there for the energy for next 2 to 3 days or 2 to 3 months, what is the cost of energy, and what are all the upcoming holidays, what may be the energy used for the holidays. All these things, it will be done by a AI agent, just like the operator. Then it will be automatically scheduling it. I know at least 3 to 4 top level AI companies all around the world, which is primarily working over this domain exclusively for electrical domain. There are teams exclusively working over electrical power grid related areas, the top AI companies. And a lot of funding and research is going on. Now, suppose one advantage I will tell you, building AI agent, it was a new innovation, right? So An experienced person within this particular domain, they may be having an experience of 1 to 2 years only maximum, even less. So if you start learning these kind of technology today, within next 2 to 3 months, you could be an base level expert over those areas. And if you could publish some good papers over those areas, it may be very easy, comparatively easy. Why is it easy? Because industry is looking for this. So most of the journal papers and everything, they may be also interested in this. Now there is less expert who is working over these areas. So what you can do, you could create some papers where AI agents are being used for electrical domains or mechanical domains, how it can be used. I have added the last point in the left side. You could see talent shortage. I have not just added because just as a point, regular point. No, it's not like that. I genuinely got feedback from multiple HRs saying that they are struggling a lot. They are even ready to pay 20 lakh or 30 lakh or even 40 lakh per year, but they are not getting some good people who can work over these areas. And they don't need experience for 5 years or 10 years or 20 years. They are saying that even if they are having experience of 6 months, but they should know how to use these things. But they are not getting good number of people. Just check with these domains. There is a lot of domains which is unexplored, which you can combine with your domain, then work on it. Then one of the most trending topic now, which is sensors monitoring. So when it comes to sensors and monitoring, now one problem we are facing is that if you just check with the smart sensors which have been used previously, like, just give me a second, let me just show you. One second. Motorola as well as many other organizations are providing these kind of chip. Okay, this is an old model chip where we'll be primarily selecting, or we'll be primarily just collecting voltage, power, and power factor primarily, and based on that the calculation will be done. But nowadays we are not just calculating voltage, time, and then making the decisions. We will be also checking which time they are using, what is the anomaly within the usage, whether there is a whether what is the usage for last 5 years or last 5 months. We are collecting a lot of data from users. Okay, now processing these kind of data, because previously when it comes to smart meters and sensors, we used to collect voltage, current, then what is the usage, based on that we used to make decisions. Okay, but now we are not just collecting that, even we are collecting what equipments they are using for a particular room, what is the usage, like a lot of additional data have been collected. Now what is the problem? Analyzing these kind of data with conventional chip technologies and everything, it is very, very difficult. Suppose if we are using some high level computers and everything, then it will be costly. No one will be able to pay for that. So now many organizations, they are moving to, there is a technology which is called as cloud CDN. Cloud CDN. Okay, so using cloud CDN, this particular technology, I am showing it for Google. Many other organizations are also providing. So using cloud CDN, what you can do, you could collect proper data from your consumers, and there itself, with some technological enhancement, you will be able to perform analysis. The point I want to make is, this is a technology which is being used within industry. But just check over internet, how many academic papers are using edge cloud technology with uh, you know uh, this IoT or sensors monitoring and these kind of things. Very limited, I will say very limited. Whereas industry and many organizations, or even the trend is going over these areas. So if you could learn this and work on this, there is a lot of opportunity. Okay, combining your electrical engineering knowledge or your mechanical engineering knowledge or instrumentation related knowledge to latest technologies which is being used within industry. So this cloud CDN will be more useful within the industry than the simulation tool I talk, which have been taken within each and every organization within India. Okay, now there is also a lot of research going on customer management. Okay, see, currently if you just check with the demand response papers all around the world, just check with the demand response papers all around the world, 99% of the papers will be saying that I'll be collecting the how much demand is there, and based on that I will create some algorithm which can create the demand response. 99% of the papers. But nowadays there is a lot of technology enhancements are there which may be using Gen A or ChatGPT related tools which can predict demand or which can interact with the customer like a chatbot and make the energy decisions. If you just check that, there is less number of papers. And I know many organizations, many industries are running behind this, how they can create all these things. One more item, robotic process automation. I don't know how many of you are using that. Robotic process automation. There is a lot of opportunities for this using robotic process automation, which will be mimicking whatever activities we are doing within our computers. If you could combine your technological niche, say you're working over solar energy, you're working over the solar demand protection and everything. If you could combine your technology with RPA, there is a lot of scope. And one advantage with this scope is that industries are recognizing. Suppose you have some 5 to 6 good papers. Even if you want to move within industry, there may be some good openings. Apart from doing some simulation over some softwares which is not industry relevant, try to do these kind of tasks. If you are not doing these kind of tasks. Okay, now let me move to this. Yeah, I'll quickly explain. I will stop within 5 minutes, 5 to 10 minutes maximum. Yeah, one area. These are all the technical trends which is happening within industry related to these kind of areas. Sustainable development. One, quantum computing. I don't think I need to explain over that. There is a lot of research going on quantum computing, but to be honest with you, resources which is available for us to work on it is limited. Second is that Internet of Things. I don't have to explain how IoT is changing. Third is that grid scale storage integration. Most of the storage solutions are nowadays installed within a particular organization or within the home itself, consumer level. But nowadays there are many softwares which is coming, which will be taking energy from household storage system and make it to grid level storage systems, peer-to-peer energy transfer. A lot of SaaS softwares are working. Just give me a second. I will just show you one SaaS software. Just give me, I just forgot that particular name. Okay, sorry, I forgot that particular name. There was a SaaS software which is primarily working over this, which is implemented in some of the Europe-based, particularly in German-based energy storage systems, where they are collecting storage from different homes. They are making a central pool of storage system, and based on that, they are creating pricing. A lot of research papers are going over these areas. Now, one of the most trending topic, virtual power plants. You may have created virtual power plants with MATLAB or related tools where you'll be creating a simulation model. We can create the same using ChatGPT. I'm not talking ChatGPT. I'm using that particular word because it may be easy for some people to understand. But the core concept is generative AI. You could create a virtual simulation model for a particular grid using generative AI. Now, what is the advantage within generative AI when compared to MATLAB related tools? MATLAB related tools, they'll be working over predefined configuration. We may not be able to edit that particular configuration to some extent. Yeah, there may be customization, but we may not be able to edit beyond that. We may not be always able to create an anomaly or an unwanted situation within simulation tools. It's comparatively very difficult. Whereas if you create the same using ChatGPT or related tools, you could input any unwanted condition, and every unwanted condition you are inputting that particular virtual power plant model using ChatGPT is a publishable research paper. And there's a lot of videos as well as resources available how you can create these virtual models using ChatGPT or generative AI using AI agents. Okay, so and this is a very new area which was developed within 2 to 3 years. So many people are not working over this, but many industries are supporting and many journals are easily publishing these kind of things because it's highly industry relevant. So all you need to do is you need to create a virtual model using ChatGPT or related tools. Once you create that, then you could ask some unwanted questions to that particular thing, saying that suppose solar production is low and some other production demand is high at this particular moment with this particular condition, what be the output? That ChatGPT model will be giving you answers, and every answer you will be getting, it's a paper. Okay, so how you think about how easy to create a paper or even writing, we could make use of ChatGPT. So there is a website. Okay, I know some of you have already worked over this, but there is a website, Hugging Face, where you'll be able to find these kind of tools. There are thousands of tools available. Okay, where suppose you are using energy. Okay, say I will do one thing. Say I'll just search demand. Okay, now they'll be giving you a tool which can handle demand for customer retention or sometimes demand for a shopping website. Now, what is your duty? You need to customize that particular AI model to your requirement for solar power. How can you do that? If you know some basics of AI, which you can learn easily. I think most of you are well aware with the AI plans and everything. I know. I was just talking to those people who are very new to this area. But if you know some base level operations over these areas, you could easily learn. I assure you, within 2 to 3 months, you could easily learn. If you spend just 1 hour per day for 5 hours a week for next 2 to 3 months, you could easily learn how to build a model. Now you could find some good models. You could take it from Hugging Face like models. Then you could convert that for your usage. And every model you build will be a new paper. If you want to publish one paper in every week, I'm not saying it is possible. It is possible. Lot of opportunities are there. Okay. Now, yeah, this is one thing. Now, GenA, I have already told you. Now, synthetic grid simulation, which we have discussed, we can create a virtual grid, grid simulation model using ChatGPT. Energy demand scenarios. Okay, see, one simple thing I will tell you. Last week, I was working with one of my friend for creating a paper over energy demand, everything. Actually, it was his PhD paper. I was just giving some hints and everything. His primary work was providing an algorithm which can operate over different energy demand scenarios, and that system will be providing automatic demand response. Okay, so he was using a conventional machine learning algorithm using an optimization method, including a combination of genetic algorithm and some other algorithm. Okay, but he was analyzing only three different demand scenarios, just three. Okay, and for discussion, I searched over internet and I found a lot of paper, and 99% of the papers which I have seen is that it is just taking 2 to 3 energy scenarios or 4 to 5 energy scenarios, and based on that it is being published. But suppose you are using generative AI for this particular thing, I assure you, you could create 50 different energy scenarios. like one area power factor is high, one area power factor is low, one area power factor is fluctuating, one area power factor is high and demand is low, one area there is active power uh, which is sorry, one area there are reactive power combination which is not working, and all these scenarios together, how it will be working. If you know how to use generative AI well, you could easily create this scenario. Think about a situation. Suppose you are able to build such a model. I take it back. Not every week you can create a paper. Even every day you can create a paper. All you need is some research students or support, where whatever the paper you are writing, you need some manual intervention, whether it is correct or not, or some modification or something like that. I just want to share you the area or the momentum in which technology is changing. It's beyond our imagination. Now, one more, there is a lot of trends happening over conversational grid assistance. Conversational grid assistance in the sense, now, if you just check with the demand response papers all around the world, 99.99% they will be just using one algorithm or two algorithm or a combination of multiple algorithms, so that they will provide a mathematical solution for meeting the demand. But think about a situation where your grid, okay, say Adani Power will be interacting with you over a chat and give you some good solution. Say that if you run your mixie, or if you run your water pump from 8 o'clock to 9 o'clock, then your energy will be reduced 10% for next 1 month. Then you'll be saying that no, I am going to office from 8 o'clock to 9 o'clock, so I will not be available there. So what can I do? Then Adani Power, what they'll be doing, they will run some analysis and they will check with some other person whether they are available within home or not, and based on that they will create a demand response plan so that minimum energy is made. Now we are doing it on unidirectional way. The grid is deciding who will be using how much demand, but generative AI, they can decide how much power anyone want to use. Okay, 1 second. There is a software which is available from Google, which is called as Dialogflow. It is very easy to learn, very easy to learn. If you are able to use it, you could create such a model easily, I assure you. If you start learning this Dialogflow for 1 hour every day for next 3 months, okay, you could create such a model. Okay, now coming back to the topic. Yeah, and also for anomaly detection. Anomaly in the detection is there are some problems with the grid, you could make it so. I'll stop within 2 minutes. Okay, now one problem you may have noticed that now 5G is coming, right? Suppose I am creating a smart meter and it is using 5G. Okay, what will happen after 3 years? 6G will be coming. Now what should I do? I should replace my existing hardware connectivity module, then I should install 6G. Then 7G will be coming. Again, I need to spend some items. So nowadays, many industries, what they are doing, instead of using 5G, 6G or some tools like that, they are trying to create, or they are trying to communicate through Wi-Fi within the home itself. But there is a problem. When they are using Wi-Fi within the home, there are high chances that data can be manipulated or some options will be there, right? So now what they are doing, they are creating some blockchain based technology. I think most of you have heard of blockchain. I'm sure blockchain based technology which will prevent this data manipulation and everything. So there is a lot of papers are nowadays going on where we can avoid replacing the smart meter technology again and again, instead using a single technology for smart metering, and we'll be collecting data, then we'll be processing that data. Processing for that particular data, we'll be using cloud or some softwares like that. Now the last slide, energy as a service. This is coming already. It is there in some point. Even my home, we have a solar panel installed, and whatever the excess energy we are using, excess energy we are creating after our use, within solar panel, we are providing that back to the energy vendor. Now, every year, energy vendor will be calculating how much energy I have shared to the grid. They will be paying me. It is installed within my home. Okay. So these kind of technologies are coming, which is commonly called as energy as a service. A lot of research is going on. If you are looking for some funding and everything, this is one best area you could work on it, because you will be easily getting an industry support. And if there are industry support, proper industry support, DST, like many organizations are, they are highly interested within the funding. Okay, I'm stopping at this point. If we have some queries, I'm open to that. Thank you.
Dear participants, you can raise your queries now. Dear sir, thank you very much, sir. It's a very, very valuable session for us. So on account of Nurul Islam Center for Higher Education and the participants present here, I extend my heartfelt gratitude to you for your enlightening session on green energy and sustainability solutions for the future. Your expertise in data science and power system automation has provided us with a comprehensive understanding of sustainable energy practices. Your information about the Hugging Face website, the ChatGPT usage in promoting research, that really helped us about the dialogue flow. So that really helped us in expanding our research frontier, sir. So we are truly appreciate your time and effort that you have invested in sharing your knowledge with us today. So thank you, dear sir, for your invaluable contributions to our program. Thank you, sir. Thank you very much, sir.
Thank you, ma'am. Thank you for providing this opportunity. Thank you so much.
Thank you, sir.
Thank you all for joining the session. Thank you.
Okay, sir. Thank you, sir. So, okay, sir. Dear participants, our other next session will be starting in few minutes. Welcome, sir. Welcome, sir, for this FDP.
Hi, Cynthia, ma'am. Thanks a lot for organizing this entire program. And thanks for inviting me for this special session. I feel honored and privileged actually to attend this and give a valuable session to everyone. So thanks for providing this opportunity.
Thank you, sir. Thank you very much. So an introduction of the expert now. So it's my great pleasure to introduce our esteemed speaker for today, Mr. Hari Anand, an accomplished energy markets consultant at ICF, who is also a proud alumni. Mr. Hari Anand is an experienced energy markets consultant at ICF, specializing in power generation, market modeling, and analysis of Northeast US power markets. With expertise in energy and capacity market modeling, wholesale market assessment, market price forecasting, and asset valuations, he has played a key role in providing strategic insights for the energy sector. He has been with ICF for over 4 years, progressing from an energy markets analyst to his current role as a consultant. Mr. Hari Anand has worked extensively in the energy sector, providing valuable insights into asset valuations and strategic market operations. Prior to joining ICF, he gained industry experience as a management intern at Rifex Energy Limited and Numosity Technologies, where he worked on open access power markets in Uttar Pradesh and business models for EV charging infrastructure, respectively. Earlier in his career, he worked as a project engineer at Siemens, gaining hands-on experience in the installation and commissioning of integrated building management system. He also served as an instrumentation engineer at Reliance Industries Limited, focusing on the installation, commissioning, and maintenance of PTA plants. Mr. Hari Anand holds an MBA in power management from UPES, where he actively contributed as a student placement representative, and a bachelor's degree in electronics and instrumentation from Nurul Islam University. His diverse background across power markets, energy modeling, industrial automation, and project execution makes him a valuable professional in the energy consulting space. So now we extend a warm welcome to Mr. Hari Anand as he takes us through his insightful talk. Welcome, sir. Welcome to this session.
Thanks a lot, ma'am. Thanks. So shall we start, ma'am, or should we wait for some couple of minutes?
No, sir. No, sir. You can start now, sir. We can start.
Okay, fine, sure. Okay.
Thank you, sir.
Let me share my screen with the presentation slides.
Okay, sir.
Sure. So hi everyone. So today, I will be discussing on the topic as already Cynthia ma'am has already mentioned about the energy market dynamics and the role of renewable integration in modern power systems. Though I currently am more focused on the US energy power markets, but I have tried my level best to actually capture the ongoing dynamics in the Indian market and then relate those topics and the concepts behind the integration of the renewable energy systems into the modern power systems. So given the topic, the first question that we usually come up is, though we all know that renewable integration is currently possible, but the major question, is how best we can actually integrate that, the best possible methods. So my presentation today, it will be more focusing on that particular aspect of how best we can actually integrate the renewable energy systems into the modern grid, and then how the renewable integration can contribute into the energy systems in the and it can diversify the modern dynamics of the energy market in India. So before that, everyone knows that the Indian power sector, India is it is a developing nation. Similar to its nature of developing nation, even the power sector in India is evolving rapidly. thanks to the policy reforms that the government is taking the initiative, and then throughout the international level that we have the market liberalization and probably the increased adoption of renewable energy into the system, where each and every country is more engaged on the climate change, and then like they want to integrate or they want to adopt renewable energy to the max in their entire portfolio of the energy usage across their respective countries. So similar, given that even India is also one of the nation where we have like strong policies that have been captured throughout these years, where there is a scope of the energy power sector to grow in a very dynamic way. So the renewable energy integration is crucial for reducing dependence on fossil fuels and ensuring a sustainable future. So I don't know like how many of you are here aware about like that still India is more reliant on the coal production. Still the energy, still the electricity that India actually generates, it is highly dependent on the coal and other fossil fuels, due to which currently everyone is actually talking about like to reduce the carbon emissions. They are focused on the climate changes, the environmental regulations. Everyone is more focused on how to reduce these impacts that the fossil fuels actually capture into the ongoing life of us. So to that extent, like we are more focused on renewable energy integration, and it plays a very crucial role to minimize our dependence on the fossil fuels. Specifically, if you ask on the India side, and similar, if I relate that from the US sector also, even in US, though US is a highly developed nation, still in US, if you consider the entire generation portfolio, they are still reliant on the gas-based generation, similar to what like in India we rely on the coal generation aspects. So for that sake, given that each and every nation is more focused on how we can actually integrate the renewable energy into our portfolio, and we are less dependent on the fossil fuels. So this presentation, as I mentioned, like I'll be capturing the energy market dynamics and how the renewables are shaping the modern power systems in India. So as of now, I mean, of 31st December 2024, if you see like the total installed capacity in India, it is like 462 gigawatt. And as I mentioned, like the maximum out of almost like 50%, it is the coal that is contributing to that. And similarly, the next is solar and the wind, which are actually just behind that. And thanks to the reforms, thanks to the policies, thanks to the regulations that our government is taking the initiatives upon, due to which like this portfolio, this reliant on the coal is slowly and steadily like it is coming down, and like the generation across these years, it is like increasing for the solar and wind-based generation units. You can see the power sources trend installed capacity in the below graph, wherein like if you see the dark ones, the below ones, that is the coal, and you can see like how the yellow ones, the solar, and then probably the wind, they are actually increasing upon years and years going on. So this data is from 2015 to 2024. So you can see like how the solar and then the wind sources of energy have been actually been increasing in the portfolio of the installed capacity in India. So also, if you see, like the reason behind this is also the more I mean from the cost perspective, if I I mean in 2015, for installing 1 megawatt of solar panel, or like 1 megawatt of let's say if you want to actually install 1 megawatt of solar system, the cost that was actually during that time, it has been like it has come down drastically, due to which like the faster adoption of solar and wind have been it has been increasing day by day, and it has been increasing throughout the years. So the reason behind that is the capital cost, probably the cost which we say, I mean, for building a new generation unit, it has actually increased drastically from building a coal unit. I mean, it is what I mean is like the cost that is incurred for setting up a coal plant is more comparatively right now than building up a solar unit or building up a wind unit, due to which there is a faster adoption of the solar and wind generators being included into the modern systems. Talking about the energy market dynamics in Indian power sector, the Indian power sector is basically regulated. It is regulated by a body called as CERC, the Central Electricity Regulatory Commission, and then we have a proper Electricity Act on which like all the systems are basically tied up to, and the market-based mechanisms and everything are properly mentioned in those Electricity Act, and the latest Electricity Act being 2003, wherein like the entire mechanisms of the Indian power sector is mentioned, and it operates based on those. Similarly, the power generation, transmission, and distributions are governed by entities, as I mentioned, the CERC, SERC. So SERCs are the state electricity regulatory commissions, DISCOMs are the distribution companies, and then the power exchanges, which basically engages more on the short-term power trading aspects. We have like 3 to 4 power exchanges in India that are basically operated. The highest being the Indian Energy Exchange, IEX, and then we have other platforms as well like PXIL, and then we have HPX, which is in a very nascent stage, but the overall market capturing is more for the IEX, like because 95 to 98% of the energy trading actually occurs in the Indian Energy Exchange, which is the short-term power trading exchange in India. So similarly, short-term and long-term power trading mechanisms influence market pricing. So what the short-term and long-term power trading mechanisms are like, so for generating whenever a single megawatt, let's say whenever electricity is generated, so to make that into the long-term power market, or to get engaged into a particular agreement, there are like PPAs, which are the power purchase agreements, which are basically the long-term power trading mechanisms, wherein like a particular two entities actually engage in that PPA contract, and then the energy is transmitted based on a particular fixed rate or whatever is mentioned into those particular agreements. So that is another mechanism of the long-term power trading mechanisms. And then in short term, like if there is a sudden increase or sudden demand which needs to be met, then probably the DISCOMs, or probably the DISCOMs, are the distribution companies. So the distribution companies, they usually engage into these power exchanges and then seek for electricity that are basically on the short-term basis. And then based on the demand and supply that the power exchanges meet, the market pricing and other factors come into play. And then based on the market pricing mechanism, a fixed pricing is a pricing actually comes up on which like the parties purchase the power based on those particular prices. So the challenges include demand supply mismatches, transmission bottlenecks, and financial health of DISCOMs. So currently in India, the major, if you happen to see out of all these 3-4 that I have mentioned, the challenges, the financial health of DISCOMs is the worst. Currently in India, if you see, the reason behind the financial health of DISCOMs is the worst because everybody knows that there is always a role of the politics being played into the into the state into the electricity consumption that a state probably plays into. There is a high probability that subsidies are given to the consumers, the end user consumers, for consumption of electricity based on certain unit levels. So because of that, the discoms, they fall short of their finances, and then this has tremendously, it has mounted so much that the financial health of discoms at the moment, it is pathetic. So there are like mainly many initiatives that the government, probably in even the budgets, the government actually takes the initiative to overcome this section. But yeah, I mean, it's a different part of the story that we currently are not relied upon. But yes, just for your sake of knowledge, that this financial health of discoms is the worst in India at the moment. Similarly, transmission bottlenecks. This is something which throughout the world, like any system, basically this transmission bottlenecks are prevailing upon, which can't be entirely neglected upon. But still, yeah, I mean the uh, the power systems is basically they are trying to minimize this transmission bottlenecks to the max. So those are the particular challenges that currently in India also, like, we are facing on the from the perspective of the energy market dynamics. Similarly, if you see the renewable energy in India, so we have a very aggressive target of meeting 500 gigawatt of non-fossil fuel capacity by 2030, by which, like, all these initiatives on the renewable energy system, and again on the given topic, that how to integrate this renewable energy into the modern grid, and how it can be best captured, how best the grid stability can be improved upon. All these things actually happen based on this aggressive target of meeting 500 gigawatt of non-fossil fuel capacity by 2030. So as I already mentioned in the previous charts, that over the years, like, solar and wind power are aggressively moving upon, and the capacity mix across India, it is strongly reliant now initially on the solar and wind power. So those are the primary drivers of the renewable energy expansion targets that India is currently into. So to also capture all these things, like, we have key policies. As I mentioned, the energy sector in India is highly regulated. So we strongly rely on policy makings, and then we need to take approvals from the regulatory bodies in order to consider any changes into the market dynamics or the ongoing system. So we need to actually have those key policies being implemented properly. So some existing policies that we have are the renewable purchase obligations, the RPOs, and then government has also taken the PLI schemes into consideration, like the production linked incentives, and you can even add some incentive schemes to for the discoms, basically, for overcoming their financial crisis. And similarly, like, few states and some few states are also into the waiving of the charges, like the ISTS charges, which is basically the interstate transmission charges. So those are the key policies, basically, which the government is currently engaged upon for faster adoption of renewable energy into our systems. So the major investors, those who are into the renewable energy mechanisms, are the NTPC, the National Thermal Power Corporation. Though NTPC is the highest contributor of the thermal-based power in India, it is the big player in the power sector. But slowly and steadily, even NTPC also knows that in order to sustain in the longer run, like, they need to transform their portfolio mechanisms from only reliant on the thermal power to, like, they need to step into the renewable energy sources as well. So NTPC is also currently into that, and they are now into the renewable energy domain as well. And then similarly, Adani Green and then Renew Power. We have other major chunk of players like Vari Energies and then Vikram Solar and all. which basically are the other major investors that are into the renewable energy systems in India. So now a quick background about the grid that India has. So initially, like we had 5 different grids in India, basically the north, south, east, and then the northeastern. So in October, this is basically the timeline of the changes that have actually occurred over the years. So in October 1991, like 5 regional grids were operating at at 5 different frequencies. So in India, like currently, if you see the frequency at which the grid operates, it's like the 50 hertz frequency. So initially, if you see like when in 1991, like 5 regional grids were operating, so they had different frequencies on which like all the 5 different grids were operating upon. In October 1991 to March 2003, like 4 grids out of the regional grids, like eastern and northern northeast ones got synchronized, but the other 3 remaining, like they were still operating in the different frequencies. In 2003 2006, like again 3 out of the 5 regional grids operating, they got synchronized, west synchronized with eastern and northeastern. Still, like there were 3 different grid frequencies upon which the entire nation's grid was operating upon. In 2006 to 2013, like 2 distinct frequencies of like north synchronized with central, and then like we had like 2 different frequencies upon. And currently, after December 2013, we have one nation, one grid policy, with which like all the 5 grids have been synchronized upon. And then so what it basically means is like at the moment, like all the 5 grids operate at the same frequency of 50 hertz. So the challenges and roadmap, if you see like renewable power generation, being though renewable power generation is the best source of power, considering the sustainability and probably long run, if you see like the renewable power generation is the best methodology, but it's the only issue with the renewable power generation is its intermittency nature, because of which like it produces variable output as a function of time. So that is the major challenge of integrating the renewable power into the grid. The second challenge being like managing generation variability with variability on demand side. So meeting the supply and demand is again a big challenge, which again there are like even if you consider from the Indian perspective or from the other nationwide perspectives, like this is something which requires huge amount of analysis to be taken upon in the background, considering those like meeting up the supply and demand is a big challenge. So that's the second challenge you can consider on. Similarly, the controllable aspect is the generation. Like we can definitely control the generation based on like we can reduce the PLF, which is the plant load factor. We can slow down the generation to a certain extent, or like we can improve the generation if it is like if it is operating, let's say at a if it is operating at a factor of let's say 61-70%, like then we can at least ramp it up to 80-90% based on the generation. But the uncontrollable thing is the demand side, because no one knows like at what time like the demand is going to increase. I mean, whether it is going to reach the peak, or whether the demand is suddenly going to ramp up, or it will be stable. Nobody knows that. So to analyze, to capture this variability factor, it's the biggest challenge, which already like the second point more or less covers. Similarly, the solution behind for overcoming this, the aggregation of renewable generation over a large geographical area. Currently, the another problem with the renewable source of power generation is that there are, although like many states have already adopted renewable generation across their states, but if you consider the generation that occurs from those renewable generation, it might be varying based on the capture rates, the solar capture rates or the wind capture rates. So in order to overcome all those aspects, and in order to in order to think about the reliability of the grid, aggregation of the renewable generation is the practice that can be actually adopted upon, and it can act as a intermittent, or it can act as a sudden solution to overcome the issues with the renewable generation and then capturing them into the grid. Similarly, the output aggregation that I mentioned, like it results in an overall decrease in variation as a function of time. So that's the entire solution that that can be actually a roadmap going forward for integrating the renewable energy into the grid. So in a just like if you see the impact of renewable integration, like the grid stability is the major thing that needs to be kept at the back of the mind. Like the variability of solar and wind energy poses the operational challenges, as I already mentioned in the previous slides. Forecasting and scheduling. So forecasting and scheduling is again the same thing, that is the demand and supply. Like we need to forecast the demand, and based on the current demand, like we need to schedule it so that like there are no outages at certain point, or like there are no outages that a particular segment of the consumers face, and then the other in order to compensate the other segment of the consumers. So that forecasting and scheduling needs to be properly managed. So for that, like advanced weather forecasting and AI driven predictive analytics improve the reliability of capturing the current capturing the demand and all. So the forecasting and scheduling aspect is something which needs to be again considered upon. Then energy storage, which is the battery energy storage. It acts as the battery energy storage and probably the pump hydro storage. It can manage this intermittency of the solar and wind. So a hybrid model can be built upon which actually is a combination of either the solar and the battery storage, or wind and battery storage, wherein like we can at least store the solar and wind energies into these batteries, and can be used upon wherever whenever there is a sudden ramp, or whenever there is a peak load, peak demand that actually occurs into the system. So for that, energy storage and pumped hydro storage can be the possible methodologies which can be adopted for integrating the renewable into the systems. Then obviously the market reforms, like at the moment, like we have in the short term, as I mentioned, the power exchanges in India. So we have various products across the markets. Like we have day-ahead markets, which basically is the wherein like the forecasting and scheduling happens one day prior to the dispatch of energy. And then like we have real-time markets, which is in short called as RTM markets, which happens across like 15-minute time slots. So so what it means is like for the next 15 minutes, if you have a slot wherein like you need to if you need to have the power being dispatched, like you can take part in the real time markets. Obviously the pricing and dynamics do change across these market based products, but yeah, I mean these are the market reforms. And then the ancillary services, which definitely is the key player for the grid operations, and then for keeping up the health of the energy grid. So if you see the initiatives and future outlook, so these are few initiatives that can be taken into consideration for faster adoption of renewable energy into the grid. So we have like green energy corridors, which the Indian government has already stepped into, and like they have taken this into consideration for implementing for this renewable energy integration into the grid. Similarly, the wide area measurement, as I mentioned, like aggregation of the geographical areas into a pool of let's say pool of energy being captured at a particular place and then like injecting that to the grid. That can be a methodology into consideration. So it also captures the it also requires better visualization of the grid parameters and then keeping up the grid's health to keep it stable across. Similarly, renewable energy management centers also play a wider role, like the implementing of SCADA, the security constraint acquisition and data, security constraint data acquisition systems, the scheduling of RE, and then controlling the entire systems into from a particular place, and then forecasting of the energy from one instant. That can be a possible methodology for integrating the system. And then similarly, as I already mentioned, the battery energy storage system plays a vital, significant role in the integration of renewable energy technologies into the grid. Few other initiatives are like the green hydrogen, which is again a key source of power, which is also called as the future power if you consider it into the current industry 2.0. So the green hydrogen is an emerging key source of energy, which can be used or which can be thought about in again of integrating into the grid. But again, although this is a new source of energy generation, but still like grid reliability and all is similar probably across, like for solar and wind. Whatever like whatever whatever initiatives like we need to take for integrating the solar and then the renewable energy. Similarly, like we need to also consider for the green hydrogen aspects as well. Then EVs, these are really a very what to say at the moment, like these are the big challenge that currently the even the government and even it's not only limited to government, I would say, like even all the nations are currently facing. So what they basically rely upon is like the EVs, and then charging up the EVs. It is not at a particular time frame that is actually considered upon. Like EVs can be charged at any point of time, so the demand can increase or decrease at whatever given instance that you may actually call it to. So so for out of this EV integrate, out of this renewable power portfolio, like we can use those renewable power that are generated to charge up our EVs. And then again, there are various other concepts along with EVs as well. Like there are V2G or V2X, we can call it too. So V2G is vehicle to grid system, and V2X is like you can charge it up to any system like V2H, V2B. So V2H is like vehicle to house or vehicle to building. So what it basically means is like you can charge up the EVs whenever like there is sunlight, or whenever there is whenever there is electricity that is generated from the renewable sources. And then once like uh, your uh, your purpose is solved, let's say like you have adequate amount of energy that is stored up in the battery systems of the EVs, those can be injected to the grid. So that is called as the vehicle to grid, which is a dual mechanism of charging and discharging, or like supplying the energy into the grid in certain aspects. So that also can be a possible methodology that can be adopted for integrating renewable energy systems into the grid. Similarly, smart grids and AI. So everybody at the moment, like they are talking about AI. So AI-driven grid management system, smart metering, all these definitely improve or enhance the grid's health. So integrating, definitely considering the AI aspects into the smart grid management systems also can be effective in the best possible way of integrating the renewable into the grids. And not last but the least, like policy roadmap definitely needs consideration upon, like the government and then the other bodies. They definitely need to chip in and then support for this market liberalization, and then considering upon the building up the infrastructure and the investments that are required for considering all these aspects, and then for improving the grid's health, or like increasing the grid stability across. So those policy roadmaps definitely needs to be chipped in. So yeah, these are the some initiatives and future outlook that needs to be considered. Uh, since like these are the major initiatives, or the are the driving factors that can be integrated. I will be more engaged on the smart grids and AI, and then probably the green energy corridors in my presentation, since those are the uh, current initiatives that already has been taken into consideration from the Indian energy market perspectives. So if you see the green energy corridors, so what green energy corridor is basically, it's a strategic transmission network that is developed to integrate large scale renewable energy projects into the India's national grid. So that's the main idea behind like having a separate green energy corridors in India. Like we have considered, or we have actually taken the initiative in two phases, wherein like intrastate and interstate green energy corridors have been established like in 2015 to 22, where the objective was basically to strengthen up the transmission for the 33 gigawatt of renewable energy systems that we had planned for. So this was the major players that you see, like those are the PGCIL, Power Grid Corporation of India, then the Interstate GEC, and then these state transmission utilities for the states that were actually a part of these GEC programs. So if you see the states that were into these, they were basically the Rajasthan, Gujarat, Madhya Pradesh, Maharashtra, Tamil Nadu, Karnataka, Andhra Pradesh from the southern, and then Himachal Pradesh specifically for the hydropower system. So these eight renewable rich states actually they took part in this initiative of for having a green energy corridor for better capturing the renewable energy from the renewable energy from their state portfolios, and then injecting those through the national grid. So yeah, that was the main stepping stone, you can say, for the green energy corridor that the from the Indian perspective. Similarly, a phase two also had been planned, wherein like we are still into the phase. So it covers basically like 125 gigawatt of renewable from 26 to 27, 13 renewable energy parks across multiple states like Rajasthan, Gujarat, Karnataka, Tamil Nadu, Maharashtra, like those also played into, and then ultra mega renewable energy parks also specifically from Ladakh, and I think there was another energy park from Gujarat, the Charanka National Park, that also actually took into this Ladakh and Kutch. So yeah, it covers that Kutch thing. So yeah, definitely that is also the Charanka National Park, which played the role into the phase two of the green energy corridor system. So yeah, these were basically few initiatives that the government actually took in order to capture the renewable energy systems into the modern grid. And then the smart grid. So what smart grids are? So it is basically an advanced electricity network that comprises of, you can say, like all the necessary all the latest automation, all the latest sensors into place, and then communication protocols and all other AI driven analytics being considered upon for capturing the real time data, and then controlling it from a single go. So it's basically a smart grid. So you can think it of in a perspective as DCS or SCADA, the distributed control system, or SCADA in the modern in a grid infrastructure. So that is what basically the smart grid comprises of. So the renewable energy. So what actually what is the necessity of actually considering these or like putting all these things, sensors, automation into the smart grid? Why the requirement is basically because of the renewable energy forecasting and grid balancing. The more we are into the AI driven analytics, the more we are able to digitalize things, the more we are able to monitor things on a real time basis. Like we can come up with a predictive models, or we can come up with a predictive methodology of the requirement of for requirement of the demand, and like based on those, like we can have a better forecast or have a better supply for meeting up those demands. So yeah, whenever like you are successful enough in forecasting the supply and demand, definitely it's the win-win situation for the grid balancing. So that's basically the overall you can say the overall benefit of actually implementing the smart grid into place. So yeah, I mean, also it comprises of other equipments. Let's say smart metering. So smart metering is basically from the consumer end side. So the more even the consumers are aware of, like I mean, how much they have actually utilized their energy, they can definitely improve their usage of electricity at a particular time, or like they can definitely minimize their energy consumption across, which will benefit definitely for the consumers as well, and then obviously the grid also. Like there won't be much of load, so which will be easier for the generators, or easier for the across the stakeholders in the entire power chain to manage. So yeah, that is the overall objective of implementing the smart grid. So this time of day TOD, which is basically the a tariff-based mechanism that can be also implemented. So what it basically means is uh, like we can charge the consumers based on the time durations, like whenever there is a peak demand, whenever there is consumption from the consumers during the time of a peak demand, definitely the prices will be it will be a sort of dynamic pricing that the consumers will be charged on. And definitely on the during the time of off peak hours, like if they are trying to I mean, cope up with their demand, they can be incentivized, or they can be incentivized with like charging like very less electricity tariffs during that particular time frame. Similarly, the predictive maintenance of grid infrastructure, like whenever like we are trying to implement AI into the system, if it happens to be like identifying or predicting the failures or faults into the systems, we can always like we can always play more more easier in the going forward. Like we can be resilient upon to predict those failures, and then we can try to avoid those circumstances and then plan it accordingly. So that is again a predictive maintenance system that the smart grid implementing a smart grid definitely plays into. So as I mentioned, like few power trading exchanges in India, like basically the IEX, PXIL, they have already they have already considered, or they have already tried to integrate AI into their energy trading mechanisms for identifying the supply demand and the historical price trends, and then like even to coming up with the market pricing mechanism. So all these are currently being powered by the AI algorithms that these short-term power exchanges have actually taken the initiatives upon. So yeah, all these are actually a part of smart grid initiative. So again, the grid automation and self-healing networks, which again the predictive maintenance and grid infrastructure already covers. So the more your grid is automated and the more there is a scope for self-healing networks, we'll be able to detect and isolate those faults, and then like we can we can have the grid stability intact, and then we can try to minimize the blackouts or the outages that might actually occur due to a grid failure. So those are the importance of implementing the smart grid into the modern power systems. So some smart grid initiatives that have been taken in India, like the National Smart Grid Mission (NSGM), the government actually took that initiative to consider the AI and Internet of Things and automation and automating the entire power grid into the mod and modernize it to based on all the latest technology aspects. Similarly, smart metering programs were also rolled out for 250 million smart meters under the revamped distribution sector scheme, which is the RDSS, to improve the efficiency of the smart grids across smart grid implementation in India. Then state level AI pilots programs also played into a role, like the Karnataka, Gujarat, and Maharashtra. They are actually into a pilot program of forecasting their demand based on AI for efficient renewable grid balancing. So they are actually so overall what it actually means is like many things are actually going on from the government aspects for keeping up the grid's health, and like even the governments are taking the initiative to, and they are considering or they are like thinking about how best they can actually integrate the various energy sources into the modern grid, so that like even the targets like the 300 gigawatt of target by 2030 that can be met, and then like our main focus from the fossil fuels can be shifted over to the renewable energy systems, basically the solar and wind or other sources of technologies that are currently into place. So a few case studies, again from the government aspects, like Gujarat, they have successfully integrated solar and wind through policy support and robust infrastructure. And then if you see for Karnataka, like they implemented the hybrid models for supporting grid stability, wherein what they actually did was they not only considered hybrid models specifically for solar and storage, but they also considered solar storage and wind energy. They try to integrate all the three into the battery energy storage system in the Pavagada solar parks. And then based on those, it also was a case study that can be studied upon for how efficiently we can actually integrate these renewable energy sources into our modern systems. And then some international examples we have, like generation, like the Germany and then the California. They have also implemented the battery energy storage as a solution for which definitely India has considered upon, and like even the India is also taking the initiatives to adopt for better efficiently have those renewable energy systems implemented in our model. So if you see on from the conclusion perspective, like as I already mentioned, India's energy market is an ever-growing market, and then there is a high scope for the renewable energy systems in our nation, and the main scope behind and the main study behind are this presentation or from this presentation perspective, you see like how best we can integrate or penetrate these renewable energy systems into the current market dynamics. So So that is that can be efficiently done because India has taken those stepping stones to integrate those into the modern systems. So yeah, that is from the Indian perspective. And then various grid challenges. So our grid system at the moment, like it's a very congested grid, you can say. Like there are many challenges, specifically from the transmission perspective. Like there are things that needs to be rectified upon, or there are some inefficient equipments that are being operated from the grid perspective, which needs to be addressed upon. And then like if we also consider the modern systems, let's say the storage solutions or the other solutions that we already discussed, the ancillary services, and then keeping up with the reserve margins and all, if we consider those into the current grid infrastructure, then definitely like plus like added them with the innovative policies from the government perspective, that can be best addressed for coping up with these grid challenges. So yeah, the future looks very promising from the Indian point of view. And then there have been like technology advancements across all the phases, you can say, of the power chain. So yeah, I mean, definitely from the Indian perspective, the future looks very promising for integrating the renewable energy systems into the modern grid. Yeah, thanks for giving this opportunity and for hearing my uh, insights on this. I'm definitely open to some questions. I mean, whatever you have.
Dear participants, you can raise your queries now. Thank you very much, sir.
Thanks a lot, ma'am.
Thank you very much, sir. So we are very much indebted to you. So we extend our heartfelt gratitude to you for your insightful presentation. Your expertise in energy and energy capacity marketing modeling, coupled with your hands-on experience in asset valuations and strategic market operations, has offered us valuable perspectives on the integration of renewable energy sources into the existing power systems. So thank you very much for your insightful session. And we truly appreciate your time and effort you have invested in sharing your knowledge with us. Thank you. Thank you very much, sir. Thank you very much once again.
Thanks a lot, ma'am.
Okay,
Thanks,
sir.
everyone.
Thank you, sir.
Okay, thanks.
Dear participants, so we are nearing the end of this FDP. So at 7 o'clock, we'll be starting the valedictory function. And before that, at 6:30, your assessment starts. So at 6:30, so I have already sent the instructions to your group, to the group, so you can verify that. And if you have any doubt, you can ask me. So actually, sharply at 6:30, the assessment starts. So once you start the assessment, you can take a maximum of 60 minutes for completing that. So try to complete it as early as possible so that we can complete the procedure. And moreover, I'll be sending you the eligible participants for getting the certificate. That is, those who have got above 80% or above attendance. By Sunday, I'll be sharing it in the group. So there also, if you have any discrepancy, you can contact me. So thank you very much for being with us and patiently listening to us and hearing us. So please join us by 7 o'clock in the valedictory session. So please, you can give your feedbacks to us. So that will be much appreciative for us. So we are expecting you more feedback from you, more feedbacks. Thank you very much, dear participants. Thank you.